Most people still picture the expanding universe in a way that feels almost harmless. Galaxies drifting outward, space sitting there quietly beneath them, a vast black stage, more distance, more emptiness, nothing conceptually violent, nothing that threatens the structure of reality itself. But that picture is wrong. The universe is not expanding the way smoke spreads through a room. It is expanding the way the room itself would expand if the distance between every wall, every atom, every coordinate in the floor plan began to grow at once. Not because anything pushed outward through space, because space changed. And that is where the subject stops being a piece of astronomy and becomes something far more unsettling. Because once space is allowed to change, distance is no longer a passive fact. It becomes an active process, a process that can carry galaxies away from one another, stretch light on its way to us, erase contact between futures that will never meet, and slowly redraw the boundary of what can still belong to the same visible world. The first mistake is thinking space is where things are. Space is something that can happen. And once it starts happening on cosmic scales, the consequences do not stay cosmic for long. They reach all the way into the human condition, into what can be known, into what can be reached, into what future minds will still be able to prove about the universe they inhabit. Because the expansion of the universe is not just a story about motion. It is a story about separation becoming law. For most of human history, the deeper intuition felt obvious. The heavens might be crowded or sparse, ancient or eternal, beautiful or severe, but the stage itself seemed fixed. Space felt like the one thing you did not have to question. Things moved inside it. Light crossed it. Gravity acted through it. But space itself? That seemed silent, passive, merely there. Then the silence broke. Not with a roar, not with some cinematic rupture in the sky. With measurement, with patience, with human beings looking at faint light carefully enough to realize that the universe had been confessing something strange for a very long time. That confession would eventually force us to abandon one of the most natural pictures the mind has ever built. Because a static universe is emotionally comfortable, it may be immense, but it is stable in kind. It feels like a structure you could, at least in principle, settle into. The stars may move, worlds may die, civilizations may vanish, but the arena itself remains. An expanding universe is different. It means the arena is not finished. It means the map is changing while the travelers are still on it. It means the distance between things is not just a condition of reality, but one of its active behaviors. And once that possibility is admitted, many things that seem solid begin to loosen. The meaning of far, the meaning of origin, the meaning of future, even the meaning of emptiness. Because emptiness is only simple if space is inert. If space can grow, emptiness is no longer an absence. It is a participant. That is a difficult sentence for intuition to believe. Human perception was not built for metric expansion. We evolved to judge rooms, roads, weather, cliffs, bodies in motion. We understand movement by watching something travel from one place to another. A bird crosses the sky. A stone falls. A ship disappears over the horizon. The object moves through space. Space does not enlarge beneath it. So, when people first hear that the universe is expanding, they often imagine a cosmic debris field, matter flying outward from some ancient blast, racing through a pre-existing void. It is a vivid image. It is also deeply misleading. The real picture is colder than that, and stranger. There is no need for a central blast point sending galaxies away, like fragments of shrapnel. No need for a surrounding emptiness into which the universe is swelling like smoke into air. The deeper claim is more radical. The distances themselves change. Two galaxies can become more separated, not because they are driving through a larger background, but because the geometry between them is stretching. A quiet increase, distributed everywhere. No center in ordinary space. No edge you could stand outside and watch advancing. No privileged balcony from which the whole thing finally makes intuitive sense. That is one reason cosmology feels so destabilizing when it is understood properly. It denies the mind its favorite comfort. which is the fantasy that reality must eventually resemble a larger version of everyday experience. But the universe does not owe us that resemblance. At the largest scales, reality can remain lawful while refusing to be psychologically friendly. And if that sounds abstract, there is a simple way to feel the wrongness of it. Imagine drawing a perfect grid across the universe, not with ink, but with coordinates, a map laid over everything. Galaxies do not have to race across that grid for separation to increase. The grid itself can expand. The points grow farther apart. Light crossing those intervals must travel through a changing metric. The journey lengthens while the traveler is still in transit. Nothing in ordinary life prepares you for that. It violates the body's common sense. And yet the universe seems to operate that way anyway. Which means the expanding universe is not just big science. It is a correction to one of our oldest hidden assumptions, that reality, at bottom, is built in a way the nervous system would have guessed. It is not. The deeper model is less intuitive than the visible one. That pattern will return again and again. Matter feels solid, but is mostly structured emptiness. Time feels like a universal flow, but depends on motion and gravity. Space feels fixed, but can evolve. The story of modern physics is often the story of losing the obvious world and gaining the true one. And truth, in that exchange, is rarely more comforting. Once the possibility of expansion enters the picture, a second realization follows almost immediately. If distances are larger now, they were smaller before. Smaller yesterday than today. Smaller a million years ago than now. Smaller still if you keep following the logic backward. Galaxies closer. Matter denser. Radiation hotter. The visible universe compressed into a past whose conditions no human intuition would ever have invented on its own. That backward inference is one of the most powerful habits in science. Not merely observing what is, but asking what must have been true for the present world to exist at all. An expanding universe turns the sky into history. Every great distance becomes a record. Every arriving photon becomes a delayed report from a younger cosmos. The night is no longer just scenery, it is evidence. And evidence of a very particular kind. Not that the universe contains many things, but that its scale is temporal, that size itself has a history, that the spaciousness we live inside is not original, it was achieved. The Big Bang, seen through this lens, is not the cartoon image of matter exploding into a waiting darkness. It is the recognition that the universe was once in a radically different state because space-time itself was once compressed, hotter, denser, less transparent, less forgiving. The cosmos did not burst into a room. The room was part of the event. Space entered history. That alone would have been enough to permanently humble us. But the humiliation was only beginning. Because even after expansion became thinkable, another intuition survived almost untouched, a quiet expectation that felt so reasonable it barely needed defending. If the universe is full of matter, and matter produces gravity, then expansion should gradually slow. However immense the cosmos may be, gravity should still act as a brake. The expansion may continue for an unimaginably long time, but it should be tiring, losing speed, surrendering, however slowly, to the weight of everything. That expectation matters because it sounds like more than mathematics. It sounds emotionally fair. A universe that expands, yes, but not forever without resistance. A universe whose outward motion is eventually answered by its own substance. A cosmos that may be dynamic, but not indifferent. For a while, that expectation seemed almost unavoidable. And then light said otherwise. Not all at once, not in the beginning, but faintly, across distances so large that color itself became a witness. Because if space really changes, then light does not merely show us what is out there. It arrives carrying a record of what happened to the distance on the way here. That is the first place the expanding universe stops feeling like an idea and starts feeling like evidence. Because astronomy, at its deepest level, is not the study of objects. It is the study of messages delayed by distance. Nothing in the sky reaches us directly. Every star, every galaxy, every cloud of gas, every supernova arrives as a report carried by light. and that report is already old by the time we receive it. To look far away is to look late. To measure the heavens is to work with memory. And memory, in an expanding universe, does not remain intact. Light has one great vulnerability. Its wavelength can be stretched. If a source of light moves away from you through ordinary space, the light shifts toward the red end of the spectrum. The crests are pulled farther apart. The color lengthens. In daily life, we know this effect most easily through sound. A siren approaching sounds compressed, pitched up, urgent. As it passes and recedes, the pitch falls away. The signal thins. Motion leaves a signature in the wave itself. Light can do something similar, but on cosmic scales the story becomes stranger. Because the redshift we observe in distant galaxies is not merely the mark of objects racing through static emptiness like bullets through air. It is, in the modern picture, the signature of light traveling through space while space itself changes beneath the journey. That distinction matters. A photon leaving a distant galaxy does not cross a rigid stage. It moves through a metric that is stretching while it is still in transit. The wavelength is carried along with that expansion. By the time it arrives, the light has been thinned out by the history of the universe it crossed. Motion was hiding inside color. Once that was understood, the night sky became far less innocent. Because if light can be read this way, then color is no longer just visual character. It becomes evidence of cosmic behavior. A galaxy is not merely beautiful or remote. It is measurable. Its light can tell us whether it is approaching or receding, and by how much. The sky stops being a tapestry and becomes a field of testimonies. This is one of the quiet revolutions of science. The moment an appearance becomes a witness. It is easy now to say that galaxies are receding from us. The phrase has become familiar enough to feel almost harmless. But the first astronomers who began to glimpse this pattern were not adding ornament to a stable worldview. They were disturbing the foundation of it. For centuries, the largest question had seemed almost philosophical. Is the universe eternal? Is it static? Does it have a beginning? But once light itself became readable as motion, those questions stopped being abstract. They entered the domain of measurement. And measurement is far less forgiving than intuition. The key figure in the popular version of this story is Edwin Hubble, and his name deserves its place. But the deeper shift was larger than one man. It emerged from a convergence of better telescopes, sharper spectroscopy, better distance estimates, and the dawning realization that many faint smudges in the sky were not small local objects inside the Milky Way at all, but entire galaxies in their own right, vast island universes, each carrying billions of stars. That alone changed the scale of reality. The Milky Way had long felt immense enough. Suddenly, it was one among many. The visible universe widened before we had even learned how to think properly about its motion. Then came the pattern that made the widening irreversible. The farther away a galaxy was, the greater its redshift tended to be. Not random, not occasional, systematic. Distance and recession seemed linked. That observation eventually hardened into what we now call the Hubble-Lemaitre relation, a remarkably simple law stating that the recession velocity of distant galaxies is proportional to their distance from us. The farther the galaxy, the faster it appears to be moving away. At first glance, that can sound disturbingly self-centered. If everything is moving away from us, does that make us special? Does it place our galaxy near the center of the expansion? It does not. And this is one of the first places human intuition has to be corrected with real force. If space itself expands uniformly, then every observer sees the same basic pattern. From any galaxy not bound tightly to its local neighbors, more distant galaxies recede more quickly on average. Not because one location is cosmically privileged, but because the metric growth accumulates over larger stretches of space. Distance compounds the effect. The expansion looks self-centered from every viable seat in the universe, which is precisely why it is not centered anywhere in ordinary space at all. A useful analogy is often given here, dots on the surface of an inflating balloon, and it has some value, but it also risks softening the strangeness of what is actually being claimed. The deeper point is not that galaxies sit on some cosmic skin, The deeper point is that no matter where you stand within a uniformly expanding geometry, larger separations grow faster. The law is built into the structure, not imposed from a single origin point within the space. There is no balcony outside the universe where the whole expansion finally looks intuitive. The law works, the feeling never quite does. And yet the evidence kept strengthening. Spectroscopy allowed astronomers to identify familiar atomic fingerprints in the light from distant galaxies, specific lines associated with known elements. These lines appeared shifted toward longer wavelengths, and the amount of shift could be measured precisely. Distance estimates, though difficult and initially imperfect, became better. The two datasets began to talk to one another. The farther the galaxy, the larger the shift. A relationship emerged out of the noise. This was not just a new fact about the heavens. It was a new type of sky. Before this, distance had often felt passive. Things were far because they were far. Vastness was an arrangement. But once redshift and distance locked together, vastness became dynamic. The sky was not merely full of separated objects. It was full of objects whose separation was increasing according to law. The universe was not only large, it was actively becoming larger. And there is a psychological difference between those two statements that should not be underestimated. A large static universe can still feel architecturally complete. You may never cross it, but you can imagine it as a finished thing. A universe whose scale is changing is different. It behaves less like a structure and more like an event. You do not simply inhabit it. You inhabit a process. That is one reason cosmology produces a special kind of vertigo. It is not only the size that destabilizes, it is the realization that the size is not fixed in kind. The room is changing while you are inside it, which means that every photon reaching us from a remote galaxy is doing more than showing us what that galaxy once looked like. It is also carrying a record of how much the universe expanded while the photon was on its way. The light has been altered not by accident, but by history. The night is under revision even while it is being observed. This is where the expanding universe begins to reveal one of its deepest features. It converts distance into time and time into structure. A galaxy 5 billion light-years away is not simply remote. It is visible as it was roughly 5 billion years ago. A galaxy 10 billion light-years away is not only farther, it is younger in appearance, because its light began its journey earlier, when the universe itself was younger. When we look far enough, we are no longer comparing places. We are comparing ages of reality. That is an extraordinary thing for a species like ours to be able to do. By measuring stretched light, we can read the universe diachronically. We can build not just a map, but a developmental history. The cosmos ceases to be a static collection and becomes a layered archive. Nearby galaxies show us a later universe. Remote ones reveal earlier chapters. The greater the distance, the deeper the time. And once that habit of thought takes hold, the next inference is almost impossible to avoid. If more distant galaxies show a younger universe, and if that younger universe was denser because expansion had progressed less far, then the logic does not merely suggest motion, it suggests origin under radically different conditions. The present universe is spacious, cold by early standards, and transparent enough for stars and galaxies to shine across immense intervals. But a younger universe, read backward through expansion, would have been more crowded, more energetic, more compressed. Keep following the pattern, and the old static picture does not merely weaken, it collapses. This is why the discovery of redshift was not the end of the story. It was the opening of a trap door. At first it tells you galaxies are receding. Then it tells you the universe had a hotter, denser past. Then it tells you that what we call the beginning may not be an explosion inside space at all, but a state in which space-time itself was once compressed into conditions so extreme that the familiar categories of ordinary experience, up, down, inside, outside, before, after, begin to lose their everyday meaning. A good scientific discovery does not just answer a question. It changes which questions can still be asked honestly. And once redshift established that the universe was not static, the entire cosmological problem was rewritten. The old task had been to explain a world that simply existed at scale. The new task was far harder, to explain a world whose scale had evolved. That shift is easy to underappreciate because we now inherit it as background knowledge. But there was nothing inevitable about it. The human mind prefers a finished stage. It prefers permanence in the frame and movement only among the actors. An expanding universe removes that comfort. It tells us the frame itself participates. And once the frame participates, the past becomes physically different in kind, not just in content. That is the road leading toward the Big Bang, not as a popular image, but as an inference forced by the history written into light. But before that inference could mature into a full cosmological narrative, one more instinct still had to be honored. Because even if the universe was expanding, there remained a powerful reason to expect that expansion would eventually slow. After all, the cosmos was not empty. It contained matter, and matter has weight. And weight, in a universe ruled by gravity, is never passive. That was the next great intuition. Not naive this time, not something inherited from ancient skywatching or bodily common sense. This one came armed with mathematics. If the universe is full of matter, then every galaxy, every cluster, every filament of gas and dark matter contributes to a mutual inward pull. Expansion may have begun, however that beginning is to be understood, but gravity should oppose it. It should resist the widening. It should lean against the growth of distance the way a stretched spring leans against being pulled further apart. So, once the expanding universe had been accepted, the question was no longer whether reality was dynamic. The question became whether it was spending itself. That shift matters because it is the point where cosmology ceased to be a story of discovery alone and became a story of fate. If expansion slows enough, perhaps the universe could one day stop. If matter is dense enough, perhaps the whole outward motion could reverse. A cosmos that begins in fire might someday collapse back toward itself. Even the more restrained versions of that picture still assume the same basic principle. Gravity gets a vote, and over long enough timescales. Gravity is patient. Emotionally, the idea has a certain severity to it. The universe can change, yes, but not without resistance, not without consequence. Outward motion must answer to substance. The cosmos cannot simply drift free of its own content. For much of the 20th century, that expectation seemed almost unavoidable. And to understand why, it helps to move from the observational shock of expansion into the deeper architecture that made expansion intelligible in the first place. Because galaxies receding from one another was not merely an astronomical curiosity, it was the visible expression of a more radical idea. Gravity is not just a force acting across space. Gravity is geometry. That sentence marks one of the great turns in human thought. Before Einstein, gravity was usually imagined in something like Newtonian terms, masses exerting attraction across distance, pulling on one another through an invisible but mathematically precise influence. Newton's framework was astonishingly powerful and remains extraordinarily useful, but general relativity changed the conceptual center of gravity, almost literally. It proposed that mass and energy do not simply act within spacetime as though on a passive stage. They shape the stage itself. Matter tells spacetime how to curve. Curved spacetime tells matter how to move. So, when cosmologists began applying general relativity to the universe as a whole, they were not merely asking how objects move against a fixed backdrop. They were asking what kind of global geometry a universe full of matter and radiation would possess. And the answer was uncomfortable. Einstein's own equations did not naturally prefer a static universe. Under broad assumptions of large-scale uniformity, they tended toward dynamical solutions, expansion or contraction. A universe filled with matter should not simply hang in place forever. Geometry and content would not permit that kind of perfect suspension. Einstein, famously unsettled by this, inserted an extra term into his equations, the cosmological constant, in an attempt to hold the universe static. A mathematical brace, a counterweight, something to keep the cosmic architecture from either falling inward or flying apart. That move is often told as a cautionary anecdote, and in one sense it is. But there is something more human and revealing inside it. Even one of the greatest physicists who ever lived felt the pull of the old preference. the desire for a universe whose deepest frame remains still. Reality had other plans. Once expansion entered observation, the static model lost its emotional privilege. The cosmos was not an eternal arrangement, it was a changing geometry. And once that much was granted, the next issue was quantitative: how much matter exists, and therefore how hard is gravity pulling against the expansion. This is where cosmology acquired one of its most elegant and pitiless habits. It began treating the universe almost like a thrown object. Launch something upward from Earth, and gravity begins working against the motion immediately. The object may continue rising for a while, but it slows. Its future depends on the balance between initial outward motion and the inward pull of mass. Too little speed, and it falls back. Enough speed, and it escapes. Right at the threshold lies a delicate boundary between eventual return and endless departure. The universe invited a similar question, but at scales so large the analogy becomes both useful and inadequate. Expansion is not a projectile moving into external space. Still, the balance between outward metric growth and inward gravitational attraction can be framed in a comparably stark way. If the average density of matter and energy in the universe is high enough, gravity can eventually halt and reverse the expansion. If it is low enough, expansion continues forever, though in the older picture, it should continue while gradually slowing. Everything depended on density. How much matter is there, really? Enough to close the cosmos back on itself? Enough only to weaken the expansion but never reverse it? Or so little that the universe remains open, forever enlarging into thinner and colder states? This was not just bookkeeping. It was metaphysics with measurements. Because different answers implied different destinies. A closed universe might one day collapse in a final global contraction. An open universe might expand forever, stars burning out one era at a time, structure thinning into loneliness. A critical universe, balanced exactly at the boundary, would expand forever too, but ever more slowly, with the rate of expansion asymptotically approaching stillness without quite arriving. The beauty of these models is austere. Each fate emerges not from mythic temperament, but from geometry and density. The universe's future becomes an equation about what it contains. And what it contains, at first glance, seemed to support the old expectation of breaking. After all, the sky is crowded. Galaxies gather into clusters, clusters into superclusters, matter clumps, gravity binds. Everywhere you look, the large-scale universe shows the fingerprints of attraction, sculpting structure over time. Gas falls inward. Stars form inside collapsing clouds. Galaxies merge. Massive bodies bend trajectories and trap companions in orbit. Gravity does not feel hypothetical. It feels sovereign. Even more, by the late 20th century, astronomers had already been forced to accept that visible matter was not the whole story. Galaxies rotated too quickly at their edges. Clusters held together more tightly than luminous matter alone could explain. Gravitational lensing revealed more mass than telescopes could directly see. Dark matter entered the picture not as decorative mystery, but as a hard necessity. Whatever its nature, it added still more gravitational substance to the universe. So, if ordinary matter pulls inward, and dark matter pulls inward too, then the expectation of deceleration only hardens. Everything we knew about gravity said the universe should be tiring by now. This is what made the next chapter so extraordinary. It was not a correction to a childish intuition, it was a wound delivered straight through the center of a sophisticated one. But before the wound, there was a long interval in which deceleration was not merely plausible. It was the governing assumption behind serious observational efforts. Astronomers did not go out into the sky expecting to find acceleration. They went out trying to measure how much the expansion had slowed over cosmic time. This is a crucial difference. Reality did not merely surprise us. It surprised us in the direction opposite to what our best framework had prepared us to see. That framework was expressed mathematically in the Friedmann equations, derived from general relativity under the assumption that the universe is homogeneous and isotropic on large scales, roughly the same in every direction and place when viewed from far enough away. These equations relate the expansion rate of the universe to its contents: matter, radiation, curvature, and, if included, the cosmological constant. You do not need the full equations to feel their conceptual weight. They tell us that cosmic expansion is not a mood or metaphor. It is a dynamical quantity determined by what the universe contains and how that content behaves as space grows. Matter dilutes with expansion. Radiation dilutes faster because its wavelengths stretch as well. Curvature influences global geometry, and any cosmological constant, if real, contributes differently again. But for a long stretch of cosmological thinking, the dominant intuition remained matter-centered. In a matter-filled universe without some strange additional ingredient, expansion should decelerate. The only questions were how much, and toward which ultimate fate. This is where language like open, closed, and flat entered the story, though these words are often misunderstood. They do not simply mean open like a door or flat like a sheet of paper. They refer to the geometry of spacetime on cosmic scales, whether large-scale curvature bends one way, the other way, or balances at the critical threshold. These geometric possibilities are tied to density. Too much matter energy, and geometry curves one way, too little, another, exactly enough, and the universe sits at the critical boundary. Again, destiny emerging from content. The remarkable thing is how reasonable all of this felt once expansion itself had been accepted. The universe begins hot and dense, expands outward, and gravity slowly works against that expansion according to the amount of matter present. Elegant, severe, intellectually satisfying. It gave the cosmos a narrative shape the mind could live with. A beginning, a struggle, a measurable future. And behind it all, a comforting asymmetry. Gravity still seemed like the adult in the room. Expansion could happen, but gravity would adjudicate. It is difficult to overstate how deeply that expectation shaped the field. When astronomers sought better distance indicators to measure the expansion history of the universe, they were not merely gathering more data out of abstract curiosity. They were trying to determine the cosmic deceleration parameter, to read directly from the sky, how strongly gravity had been applying the brakes. Some hoped the universe might be dense enough to someday recollapse. Others suspected it would expand forever, but more slowly. The debate was open. The principle was not. The principle was that the expansion should be slowing. That is why the next observational strategy had so much pressure on it. To settle the matter, cosmologists needed objects bright enough to be seen across immense stretches of time, and regular enough in their intrinsic brightness to act as distance markers. They needed signals from far enough away that the universe's past expansion history would be written into their faintness. In other words, they needed a ruler made of catastrophe. They found it in dying stars. Not every kind of dying star would do. The universe is generous with explosions, but not with trustworthy ones. Most stellar deaths are messy, asymmetrical, dependent on details that vary from star to star: mass, composition, environment, rotation, magnetic fields, timing. If you want to use an explosion as a measuring tool, that variability is fatal. A ruler that changes length each time you pick it up is not a ruler at all. What cosmologists needed was something rarer, an event so violent that its brightness could still be seen across billions of light years, and so regular that its luminosity could be calibrated with confidence. They found it in one of the most severe arrangements in astrophysics. A white dwarf is what remains after a star like the Sun exhausts its nuclear fuel and sheds its outer layers. No fusion in the core, no fresh energy being generated to resist gravity. And yet, it does not immediately collapse, because it is held up by something stranger than heat. Electron degeneracy pressure, a quantum mechanical effect arising from the fact that electrons are not willing to be compressed indefinitely into the same states. A white dwarf is matter at extreme density, stable not because it is warm, but because the microscopic rules of quantum physics refuse to let it collapse any further. Already, it is a reminder that the universe often preserves structure through principles the body would never guess. But in the right binary system, a white dwarf does not remain quietly stable. If it orbits close enough to a companion star, it can siphon matter from that neighbor. Gas spirals in, mass accumulates, pressure rises, the white dwarf grows heavier, closer and closer to a limit beyond which its internal support can no longer keep pace. That threshold is known as the Chandrasekhar limit, roughly 1.4 times the mass of the Sun. Cross it, and the star does not merely become unstable. It detonates. The carbon and oxygen in the white dwarf ignite in a runaway thermonuclear reaction so rapid and so complete that the star is effectively unmade. A large fraction of the dwarf is fused in a matter of seconds. The explosion releases an immense amount of energy, often shining with a luminosity comparable to an entire galaxy for a brief period. This is a Type 1a supernova, and for cosmology, it was close to miraculous. Because although no astrophysical event is perfectly identical, Type 1, supernovae are regular enough that, once carefully standardized through their light curves and spectra, they can serve as what astronomers call standard candles, objects whose true brightness is known or can be inferred well enough that their observed faintness tells us their distance. That phrase, standard candle, sounds almost quaint, but what it really means is that a star's death can become a ruler. Not a ruler of metal or wood, a ruler made of thermonuclear collapse, visible across the abyss. If you know how bright an event truly is, then the dimness with which it reaches you becomes information. Light spreads out. Distance weakens apparent brightness in a predictable way. So, by comparing intrinsic luminosity with observed luminosity, astronomers can estimate how far away the explosion occurred. This is elegant in the way some of the greatest scientific methods are elegant. It turns destruction into precision. And once redshift was already available from spectroscopy, Type 1. Supernovae offered something more powerful still. They could pair distance with cosmic recession. They could reveal not just how far away remote galaxies were, but how the expansion of the universe had behaved over time. That was the real prize. Because if gravity had been steadily slowing the expansion, then the ancient universe should have expanded faster than the present one. Looking far away means looking back in time. So distant supernovae should carry the imprint of that decelerating history. Their brightness at a given redshift would tell us whether the expansion had indeed been losing speed, and by how much. The method was straightforward in principle, brutal in practice. These explosions are rare, they fade, they have to be found quickly, classified correctly, measured carefully, corrected for dust, compared across different host galaxies, and mapped against redshift with painstaking attention to error. The farther away the event, the fainter it appears, and the more merciless the observational challenge becomes. At large redshift, astronomers are trying to reconstruct cosmic history from brief flashes of light that may have traveled for billions of years through an expanding universe before landing on a detector inside Earth's atmosphere, or, later, above it. This is not passive stargazing. It is forensic cosmology. Teams spent years building these datasets, one supernova at a time. And what makes this chapter so powerful is that they were not wandering blindly through mystery. They were asking a very specific question inside a very specific framework. Given general relativity, given a universe filled with matter, given all the accumulated expectation of deceleration, what does the actual brightness of distant supernovae say about the breaking power of gravity? The universe answered with a discrepancy. At first, discrepancies are fragile things. They can be mistakes, calibration errors, bad assumptions, selection effects, unaccounted dust, misleading statistics. Science is full of ghosts produced by instruments or methods. Responsible researchers do not fall in love with anomalies too early. They push on them. They try to break them. They try to make them disappear. But this one did not disappear. The distant Type 1, supernovae, were dimmer than they should have been in a decelerating universe. That sentence contains one of the great shocks in modern science, and it is easy to miss its force because the logic feels technical. So, it is worth slowing down and feeling the structure of it. If a supernova has a known intrinsic brightness, and you observe it to be dimmer than expected, then it is farther away than expected. If it is farther away than expected for its redshift, then the geometry of cosmic expansion has not evolved the way a decelerating universe would predict. In other words, The ancient light arriving from those supernovae implied that the universe had expanded more than gravity alone should have allowed. The ruler had come back longer than theory was prepared to accept. We built a ruler for the cosmos, and it returned an insult. Not to observation, to expectation. This is one of the rare moments where the scientific drama is almost perfect. The measurement was designed to quantify the slowdown, and instead, it found evidence that the expansion was not simply continuing. It was behaving as though something had, over cosmic time, begun pushing the large-scale universe apart more aggressively than matter could pull it together. That does not mean astronomers instantly declared acceleration. The result had to be challenged from every angle. Could distant supernovae have evolved in ways that made them intrinsically different from nearby ones? Could intervening dust have dimmed them without obvious signatures? Could the standardization procedures be biased? Could selection effects distort the sample? Could the redshift distance relation be contaminated by some overlooked systematic? These were not peripheral objections. They were essential. Because the claim at stake was extraordinary in exactly the right way, not fantastical, not mystical, but destructive to a very well-motivated expectation. Gravity had been cast as the breaking term in the story of cosmic expansion. To suggest that the universe was not merely evading that break, but somehow moving into a phase of accelerated expansion, was to reopen the whole cosmological framework. It is one thing for the universe to expand. It is another for the expansion to change character. That is the deeper force of the supernova result. It did not just alter a number inside an accepted model, it transformed the emotional meaning of the model itself. The old picture still had severity, a universe born in heat, cooling through ages, sculpted by gravity, expanding forever perhaps, but always with the expansion gradually weakening. There was a kind of moral texture to that, outward motion answered by inward pull, the cosmos dispersing, yes, but not without being called back by its own mass. The supernovas suggested something harsher. They suggested that the large-scale universe had entered a regime in which gravity no longer dominated the story of expansion. That does not mean gravity stopped existing. Galaxies still formed. Clusters still bound themselves together. Local structure remained shaped by attraction. But beyond those scales, in the global evolution of space-time, another term seemed to be taking over. Something whose effect was not to slow the metric growth, but to increasingly govern it. And the wound here was conceptual as much as observational. Because the old intuition had not been foolish, it had been elegant. It had been grounded in the known attractive behavior of matter, and the mathematics of general relativity applied in the simplest cosmological forms. That is why the supernova result landed with such strange force. It was not the humiliation of a crude idea. It was the humiliation of a beautiful one. The universe was not just ignoring the break. It was changing the road. By the late 1990s, two independent teams studying distant Type 1 A supernovae were arriving at closely related conclusions. The data were converging. The anomaly was becoming a result, and the result pointed toward one of the most destabilizing realizations in modern cosmology. Somewhere in the large-scale accounting of reality, there exists an ingredient or an effect whose influence becomes stronger relative to matter as the universe expands. Something that does not dilute away in the ordinary manner, something that becomes cosmologically important not in spite of emptiness, but because of it. That is the threshold where the story ceases to be merely about galaxies receding, or even about gravity failing to halt the recession. It becomes a story about empty space entering the causal structure of the universe as an active term. And once that happens, the old word empty begins to rot from the inside. Because empty had always carried a hidden promise. It suggested absence, inactivity, a lack of participation. If matter and radiation are the dramatic actors of the cosmos, then empty space sounds like the stage left behind when the actors exit, a neutral background, a silence between events. The supernova results made that meaning impossible to keep. If the expansion of the universe is accelerating, then something in the large-scale equations of reality is contributing not attractive gravity in the ordinary sense, but the opposite tendency, a kind of effective outward influence built into the behavior of space-time itself. Not a wind blowing galaxies apart, not a conventional force pushing matter through a larger void. Something subtler and more severe, a term whose influence becomes dominant as the universe grows more dilute. And that is the point where the expanding universe stops being merely counterintuitive and becomes ontologically strange. Because matter becomes less important as space expands. Radiation becomes less important even faster. Their densities thin out. Their gravitational influence on the global expansion weakens. But if there exists some component of reality whose energy density remains roughly constant even as space grows, then every new volume of expanding universe arrives carrying more of that contribution. Matter fades. The other term does not. Eventually, the balance tips. The emptier the universe becomes, the more room this new influence has to matter. That is one of the coldest ideas in modern science. A cosmos that does not merely spread outward because of ancient momentum, but one whose very dilution amplifies the dominance of whatever is driving the acceleration. A universe in which emptiness is not the absence of drama, but the condition under which the deepest drama takes control. This is where the old cosmological constant returned from the margins like an unresolved sentence spoken decades too early. Einstein had introduced that constant to preserve a static universe, then largely abandoned it once expansion became real. For a long time, it looked like an artifact of resistance, a mathematical patch fitted to reality because the true dynamics were emotionally unwelcome. But once the supernovae suggested acceleration, that same term reappeared in a wholly different role, no longer as a device to freeze the cosmos, but as a candidate explanation for why the expansion would speed up at late times. If the cosmological constant is real, if empty space itself carries a small but persistent vacuum energy, then the equations of general relativity permit precisely this kind of behavior. At early times, when matter and radiation were far denser, their influence dominated. The universe still expanded, but the attractive effect of matter slowed that expansion. Later, after billions of years of dilution, the nearly constant contribution associated with empty space began to dominate the large-scale dynamics. The expansion did not merely continue, it changed regime. The universe began, in a measurable sense, to run harder. That phrase must be handled carefully, because the subject is easily distorted by metaphor. Space is not deciding anything. Empty space is not a conscious adversary. Dark energy, if that is what the cosmological constant effectively represents, is not a substance we have bottled in a laboratory and understood in the way we understand water or iron. The science here remains responsible only if we distinguish clearly between measured effect and fundamental explanation. What had been established gradually and through multiple lines of evidence was that the universe's expansion history is consistent with a dominant component whose pressure is effectively negative and whose large-scale behavior drives accelerated expansion. What that component is, at bottom, remains one of the deepest open questions in physics. This is why the phrase dark energy is both useful and dangerous. Useful, because it names the problem. Whatever is causing cosmic acceleration contributes to the total energy budget of the universe and is not directly luminous in any conventional sense. Dangerous, because names create the illusion of understanding. Once a mystery receives a label, the mind is tempted to treat the label as an explanation. But dark energy does not tell us what the thing is in the way electron or hydrogen points toward a tightly constrained theoretical structure. It tells us that the universe behaves as though some dominant, non-luminous component is shaping its expansion. It is a placeholder with teeth. And yet even placeholders can redraw reality. By current measurements, ordinary matter, the stuff of stars, planets, gas, dust, bodies, accounts for only a small fraction of the cosmic energy budget. Dark matter, invisible but gravitationally necessary, accounts for much more. And dark energy, if the standard cosmological model is even approximately right, dominates the whole inventory. The majority share belongs not to what shines, not to what clumps into visible structure, not even to the hidden matter, scaffolding galaxies from within, but to the thing we understand least. This is not just a scientific inconvenience. It is a humiliation of emphasis. Everything the human eye evolved to treat as reality's substance, the bright, The solid, the warm, the gathered turns out not to be the main term in the universe's large-scale fate. Stars are spectacular, but they are not cosmologically sovereign. Galaxies are grand, but they are not running the metric. The visible universe is not the dominant layer of the real. That theme has repeated through modern science often enough to sound familiar, and still, it lands with force every time. The obvious world is rarely the governing one. There is also something unsettling in the timing of it. Dark energy appears to dominate not in the earliest universe, when radiation ruled, nor in the middle epochs when matter drove structure formation most strongly, but relatively late, after galaxies had formed, after stars had begun long eras of burning, after planets and chemistry, and eventually conscious observers, could emerge inside a universe already old. This late-time dominance gives the expansion history a strange emotional contour. For billions of years, gravity mattered most in the cosmic tug-of-war. Structure grew, matter gathered, the universe cooled, but not yet into emptiness. Then, slowly, the balance shifted. The large-scale expansion ceased to be a story mainly moderated by matter and became one increasingly governed by the properties of space-time itself. The familiar actors remained on stage, but the stage acquired causal authority. That is the midpoint of the whole story, not just observationally, but philosophically. We begin with galaxies, then we graduate to expansion, then to a hot, dense past, then to gravity's expected breaking role, and finally, in the turn that changes the meaning of everything before it, we discover that empty space is not innocent. Once that happens, the universe becomes harder to domesticate emotionally. Because a matter-dominated cosmos still feels intelligible in human terms, matter attracts matter, mass shapes destiny. The visible and the heavy exert command. This is severe, but it is legible. It resembles the intuitions of weight, pressure, gathering, collapse. A dark energy-dominated universe is different. It is lawful, but not familiar. It says the future of the cosmos is not determined primarily by the things that look substantial. It says dilution itself can uncover the dominant term. It says that what seems like less matter per volume, less structure per distance, more emptiness, can reveal more power, not less. That reverses something deep in our instincts. We expect fullness to dominate emptiness. We expect concentration to defeat absence. We expect the dense to matter more than the sparse. Cosmic acceleration suggests that, at the largest scales, under the right conditions, the opposite becomes true. The less crowded the universe gets, the more decisively this hidden term shapes the whole. And yet the story is not finished just because the equations permit a cosmological constant and observations are consistent with it. In some ways, this is where the deeper mystery begins. Because if dark energy is vacuum energy, if empty space has an intrinsic energy density, then even the roughest attempts to calculate that density from quantum field theory produce answers so catastrophically large compared with the observed value that the mismatch becomes one of the most embarrassing numerical failures in all of theoretical physics. Not a factor of 2, not 10, not 1,000. A disaster of scale so extreme that it feels almost like a warning label attached to the edge of our current understanding. That means we are in an awkward position, scientifically honest, but philosophically exposed. We have powerful evidence that the universe is accelerating. We have mathematically coherent ways of representing that acceleration. We have a standard model of cosmology that fits a great deal of data astonishingly well. And yet, when we ask what the dominant term in the cosmic future actually is, at the most fundamental level, the answer begins to dissolve. We may know what empty space does without knowing what empty space is. And when science reaches that point, the uncertainty is not a weakness to be hidden. It becomes part of the truth. Because the most unsettling discoveries are often not the ones that hand us a clean new picture of reality. They are the ones that reveal a real effect so clearly that we can no longer deny it, even while the underlying ontology remains unfinished. Dark energy belongs to that category. A measured wound in understanding, a name attached to a fact large enough to reshape the future of the universe. but elusive enough to remind us that explanation and description are not the same achievement. And once you admit that empty space may have this kind of power, another intuition has to be abandoned too. The old picture of the universe growing into something larger. Because that picture survives for the same reason so many false pictures survive. It is easy to imagine. A firework expands into the night, smoke billows into air, ink spreads through water. A shock wave moves through a medium already there to receive it. Our minds are built from scenes like that. Motion makes sense when there is a container. Growth makes sense when there is an outside. So even after people learn that the universe is expanding, many still quietly hold on to the older image underneath the language, the cosmos, as a kind of immense object swelling outward into some larger emptiness beyond its edge. But that image does not solve the mystery. It imports the wrong one. Because if the universe were expanding into something else, the immediate question would be, where did that larger space come from? What contains it? What geometry governs it? What sits beyond that? The picture pretends to explain expansion by giving it an intuitive backdrop, but in doing so, it simply relocates the strangeness one level outward. The modern cosmological view is harsher and, in a strange way, cleaner. The universe is not expanding into pre-existing space. The expansion is the changing metric structure of space-time itself. There is no known physical requirement for an outer room waiting beyond the universe's edge. No privileged external vantage point from which the whole event can be watched like a balloon inflating on a table. In the standard picture, the question, what is the universe expanding into, is not profound in the way it first appears. It is often a sign that everyday intuition has smuggled in a container the equations never asked for. There is no outside waiting for the universe to enter. The distance itself is what grows. That is one of those lines that feels grammatical before it feels real. The words can be understood quickly. The meaning resists settlement. Because a growing distance without a surrounding arena is not how the nervous system expects reality to work. We are adapted to local mechanics, not global geometry. We know what it is for a car to cross a road. We know what it is for water to fill a glass. We do not know, at the level of instinct, what it is for the coordinate structure relating remote galaxies to evolve over time while having no center inside the system and no outer boundary into which the whole structure advances. But science is full of such demands. Understanding often begins when intuition is denied its preferred furniture. One way to approach this without corrupting the physics is to imagine not objects moving across a map, but the map itself changing scale. Suppose you draw a grid over a surface. If the spacing between the grid lines increases everywhere, then 2 points can become more separated, even if they are not driving through the grid in the ordinary sense. Their co-moving positions stay the same, while the metric distance between them grows. This is not the whole of cosmology, but it captures something essential. Galaxies at large scales can remain approximately at rest relative to the expanding coordinate flow, and yet, the proper distance between them increases because space-time itself evolves. The geometry does the work. That phrase matters because it breaks another hidden illusion, that geometry is merely descriptive. In everyday life, geometry feels like bookkeeping, a way to measure things already there: length, angle, area, volume, passive properties of a fixed world. General relativity shattered that comfort. Geometry, in modern gravity, is not just the language in which reality is described, it is part of the machinery by which reality behaves. Curvature shapes motion, expansion shapes separation, horizons shape causal access. The universe is not built on top of geometry as though using it as paper. The universe is, in a deep sense, geometric through and through. And once that becomes emotionally real, cosmic expansion starts to reveal one of its darkest implications. If the metric can grow, then not all distances are equal in what they mean for the future. Some separations remain manageable because gravity binds local systems together strongly enough to resist the global expansion. A solar system does not get torn apart by dark energy. A galaxy does not swell like rising dough. Even the local group, our Milky Way, Andromeda, and their nearby companions, remains gravitationally bound, on sufficiently small scales. local structure wins. Attraction overpowers the gentle large-scale metric trend. But beyond those scales, the story changes. Remote galaxies not bound to us are carried farther away by the expansion, and in an accelerating universe, that recession is not just continuing, it is asymptotically sealing relationships off. This is where the subject becomes more than cosmography. It becomes a theory of cosmic estrangement. Because there is a difference between something being far away and something becoming causally unreachable. Far away is a matter of difficulty. Causally unreachable is a matter of law. If the universe were expanding but slowing, then the cosmic future would still be austere, but it would not sever the same kinds of possibility. Light emitted from sufficiently distant objects would still struggle toward us through an enlarging universe, yet the long-term logic would remain more permissive. In an accelerating universe, a harder boundary emerges. There are regions whose present light can still reach us because it was emitted long ago under more favorable conditions. Yet there are also events happening right now in sufficiently distant places whose light will never arrive here at all. Not because it is too weak, because space expands too relentlessly along the way. A message can begin its journey perfectly lawfully and still never close the distance. That is one of the most haunting consequences of acceleration. It turns the universe into something more selective than mere vastness would suggest. It establishes horizons, not only in the sense that we have an observable universe limited by the age of cosmic time, but in the deeper sense that acceleration imposes event horizons, boundaries separating what can ever influence us in the future from what never will again. Expansion is not just distance increasing. It is contact being taken away. That is not poetry masquerading as physics. It is the physical meaning of accelerated separation in space-time. The future light cone of our world line does not include everything that exists. There are parts of the universe whose current state is already slipping beyond any possible future conversation with us. Not because of a wall or an explosion or a catastrophe, but because the geometry between us and them is changing too fast. And notice how severe that is conceptually. Nothing dramatic has to happen locally. The stars can still shine, galaxies can still rotate, clusters can still hold together. There is no sudden tear in the sky, no audible rupture, no cosmic siren announcing loss. The universe simply goes on, obeying its equations. And those equations, at large scales, gradually transform a richly connected cosmos into a patchwork of isolated islands. The violence is administrative. Reality revises access by law. This is where the phrase, what it means for humanity, begins to earn its place, because the meaning is not merely emotional in the soft sense. It is epistemic, civilizational, even metaphysical. A species does not only inhabit a universe physically, it inhabits it through knowability, through the ability to receive signals, build models, compare evidence across scales, and remain in causal commerce with a larger whole. If acceleration permanently narrows the commerce, then the future of intelligence is shaped not only by biology or technology or survival, but by geometry. What can be known depends on what can still arrive. And in an accelerating universe, arrival itself becomes historically contingent. That is an astonishing fact. It means there is no timeless, guaranteed relationship between observers and the cosmos. There are windows of access, epochs in which certain truths are available because the universe has not yet expanded them beyond reach. Eras in which distant galaxies still populate the sky densely enough to reveal expansion. Times when relic radiation from the early universe still bathes space detectably. Conditions under which the Big Bang is not just a theory, but an inference built from multiple observable traces. Those windows do not stay open forever. Acceleration slowly closes them. Already, when we speak of the observable universe, we are naming a limit imposed by light travel time and cosmic history. But with accelerating expansion, there is a harsher limit still. The reachable universe. There are galaxies we can currently observe whose future emissions will never reach us. We see them as they were, but there are chapters of their history that will remain permanently unwritten from our point of view. The cosmos is not only far, it is becoming selectively mute. And because language has its own traps, it is important to say clearly what this does not mean. It does not mean the universe is centered on us, or that things vanish because we matter. It does not mean dark energy targets observers, or that horizons are supernatural curtains. These are impersonal geometric consequences of expansion within general relativity and the standard cosmological model. The drama is not anthropocentric. It is worse than that. It is indifferent. The universe does not deny access because it is hostile. It denies access because law does not owe intimacy. This is the real maturity of cosmology when it is allowed to deepen beyond spectacle. At first, the expanding universe seems like a majestic fact, then a difficult mechanism, then a historical inference, then a crisis for gravity's expected role, then a mystery called dark energy. And finally, if the thought is followed all the way through, it becomes a doctrine of shrinking shared reality. The total universe may remain immense beyond language, but the portion that can still belong to a common future does not. It narrows, which means the next question is no longer merely what dark energy is, but how certain we are that this entire strange picture is real. Because if acceleration rewrites the causal structure of the future, then the evidence for it must be held to the highest possible standard. And it has been. That mattered from the beginning, because the claim was too large to rest on one elegant anomaly. No matter how dramatic the anomaly felt, a universe accelerating under the influence of something dominant and unseen is not the sort of conclusion physics is allowed to accept out of narrative satisfaction. It has to survive hostile scrutiny. It has to keep working when measured by methods that were never designed to flatter the same idea. The sky has to repeat the verdict in different dialects. And over time, it did. The supernovae were the wound. They were the first clean cut through the old expectation of universal breaking. But a wound can still be doubted. It can be blamed on dust, on selection bias, on subtle evolution in stellar populations, on calibration drift, on the 1,000 quiet humiliations that observational astronomy must always defend against. So, cosmology went looking for independent witnesses. The first of those witnesses was much older than galaxies. Long before stars existed, long before atoms could remain comfortably neutral, long before the universe became transparent enough for ordinary light to travel unimpeded, the cosmos was a hotter, denser plasma. Electrons and protons moved freely, photons scattered constantly. Space was not dark in the way we imagine darkness. It was bright and opaque, a furnace with no line of sight. Then, as the universe expanded and cooled, a threshold was crossed. Electrons and protons combined into neutral atoms. Photons were no longer trapped so efficiently by the charged plasma. Light decoupled. The universe became transparent. Some of that light is still here. Not as visible fire, but as a nearly uniform bath of microwave radiation arriving from every direction in the sky. The cosmic microwave background. This relic radiation is one of the most astonishing things science has ever found. Not because it is spectacular to the eye, it is not, but because it is a surviving surface of early reality, a fossil glow from when the universe was only about 380,000 years old. Not the beginning itself, but a surviving membrane from the young cosmos, stretched by expansion into microwaves over the following 13.8 billion years. By the time this radiation reaches us, it is cold by human standards, about 2.7 Kelvin above absolute zero, but its pattern of tiny temperature fluctuations contains immense cosmological information. Those fluctuations record density variations in the early universe, sound waves in the primordial plasma, the geometry of space-time on cosmic scales, and the total balance of matter, radiation, and whatever else governs expansion. The cosmic microwave background is not merely ancient light. It is a calibrated argument, and when cosmologists measured it with increasing precision, from COBE to WMAP to Planck, the argument grew harder to evade. The pattern of anisotropies in that relic radiation strongly favored a universe that is spatially very close to flat. That result, by itself, does not demand dark energy, but it creates a remarkable accounting problem. If the universe is close to flat, then the total energy density must be close to the critical value implied by that geometry. Ordinary matter does not supply enough. Dark matter helps, but still not enough. Something else is needed to close the budget. This is where the cosmic microwave background becomes more than a photograph of the young universe. It becomes a witness in the case for acceleration. By telling us the geometry is close to flat, while matter falls short of the necessary density, it points toward an additional component in the cosmic inventory, something not clumped like matter, not luminous like stars, but globally significant. The early universe and the late-time supernovae were beginning to agree. That is when the picture stopped looking like a clever fit and started looking like a convergent reality. Then came another witness, one subtler in appearance but equally severe in implication. In the early universe, before galaxies formed, pressure waves moved through the hot plasma like sound through a medium. These oscillations left an imprint on matter distribution, a preferred scale, and how galaxies would later cluster across space. Once the plasma cooled and neutral atoms formed, those waves froze their pattern into the large-scale structure of the universe. Billions of years later, astronomers could still detect the trace. This is what baryon acoustic oscillations really are, a fossil ruler embedded in cosmic structure. Not a ruler held in the hand, but a standard scale written into the distribution of galaxies themselves. By measuring that scale at different redshifts, cosmologists could reconstruct how the universe expanded over time. It gave them another handle on the expansion history, one independent of supernova luminosities and conceptually independent of the cosmic microwave background. And again, the data leaned the same way. A universe dominated at late times by a dark energy-like component fit the pattern best. It is difficult to overstate the epistemic power of this kind of convergence. Science is at its strongest not when one measurement is beautiful, but when different measurements, each with different systematics and different physical origins, begin narrowing toward the same architecture. Supernovae read the expansion through brightness. The cosmic microwave background reads geometry and content through relic radiation from the young universe. Baryon acoustic oscillations read the expansion through a frozen sound horizon, imprinted into the clustering of galaxies. Different eras, different mechanisms, different observational strategies. Same larger verdict. The universe did not whisper this once. It told us the same story in several languages. And there were other witnesses too. The growth of cosmic structure itself, how matter clumps over time under the action of gravity, depends on the expansion history. If dark energy becomes important and accelerates the large-scale expansion, it changes the rate at which structure can grow. Gravity still works locally, but the global tendency of space to expand faster suppresses the growth of large-scale clustering compared with a universe in which matter dominates more fully. So, cosmologists studied gravitational lensing, the bending of light by mass. They mapped how structure evolves. They measured galaxy clustering, cluster abundances, weak lensing shear, and other signatures of how matter has assembled itself across cosmic time. None of these on its own is conceptually simple. All of them are difficult. Each comes with its own instrumental and interpretive burdens. But the collective pattern is what matters. Again and again, the standard picture that includes dark matter and a dark energy-like component explains the data extraordinarily well. This does not mean every detail is settled. It does not mean there are no tensions or open questions. It does not mean dark energy is understood in a final sense. It means the large-scale behavior we are inferring, the accelerated expansion of the universe, is not balanced on one fragile pillar. It stands on an increasingly interlocked framework of evidence. That is why modern cosmology, at its best, is both bold and disciplined. It says something astonishing, but only because the sky has become stubbornly repetitive about it. The discipline matters. Without it, the subject degrades into mood. With it, the mood becomes earned. Because once the evidence has been consolidated, the emotional meaning changes again. Acceleration is no longer just an intriguing possibility. It is no longer a recent observational upset waiting to be overturned. It becomes the probable large-scale condition of our cosmic future. And that future is where the abstract science starts turning strangely intimate. Not intimate in the sentimental sense. The universe does not become personal. It remains utterly indifferent. But the consequences of acceleration move closer to the human question, because they determine not only the fate of matter in the far future, but the fate of observability itself. A cosmos governed increasingly by dark energy does not merely keep getting larger. It becomes less mutually legible. This is easiest to miss when the night sky still feels crowded. Around us there are still galaxies in the deep field, still background radiation to detect, still evidence everywhere that the universe had a hot, dense origin, and has been evolving for billions of years. We inhabit a cosmological era rich with traces. The sky has not yet withdrawn into silence. But acceleration means that this era is not permanent. One by one, on timescales grotesquely larger than human life, but real nonetheless. Distant galaxies outside our local, gravitationally bound structures will recede beyond effective reach. Their light will redshift further. Their signals will thin. The relic radiation of the early universe will stretch to wavelengths so long and intensities so faint that future observers may find it vastly harder, or eventually impossible, to detect. A future civilization, if one exists in an age old enough, may look out into a sky far emptier than ours and see almost none of the evidence on which modern cosmology depends. That possibility is one of the most unsettling gifts of acceleration, because it converts cosmology from a neutral description of the universe into a statement about historical privilege. There are truths that are observable only during certain eras. The universe is not equally transparent to all generations of minds. This idea should be allowed to sink in slowly, because it changes the human position in the story. We often imagine ourselves as late, provincial, and epistemically unlucky, tiny beings emerging long after the great cosmic events that shaped existence. And in many ways, that is true. We arrived after the first stars, after primordial nucleosynthesis, after recombination, after galaxies and clusters had already been assembling for billions of years. But there is another sense in which we may be strangely early. Early enough to still see the evidence. Early enough to still detect the afterglow of the young universe. Early enough to measure the expansion cleanly. Early enough to infer that the cosmos had a hotter, denser past. Early enough to know that the universe is not merely large, but historical. That is not a mystical claim. It is a geometric one. Acceleration places observers inside windows of knowability. Some windows open only after enough structure has formed for life and science to exist at all. Some windows close because expansion stretches the evidence beyond reach. We live inside one of those openings. And once that is understood, the question grows sharper again. Not merely whether the universe is accelerating, but what kind of future that acceleration builds. Because once acceleration is no longer a disputed anomaly, the future stops being a philosophical backdrop and becomes part of the physics. A great deal of science can remain emotionally distant while still being true. Plate tectonics does not ask for existential intimacy. Nuclear fusion in stars is magnificent, but it does not immediately rearrange the structure of human self-understanding unless you choose to follow it there. Cosmic acceleration is different. Not because it threatens us locally in any cinematic sense. It does not. The solar system will not be torn apart. The Milky Way will not evaporate tomorrow into dark energy. Human life is not endangered by the expansion of the universe in the way a species is endangered by disease, war, or impact. The disturbance lies elsewhere. Acceleration decides what kind of universe can remain shared. That is the point where cosmology becomes harder to keep at arm's length, because a civilization does not only live inside matter, it lives inside causal relations, inside a web of signals, observability, and possible exchange. To ask what the future universe looks like under accelerated expansion is to ask what survives as part of a common horizon of reality. And the answer is austere. Over sufficiently long timescales, galaxies beyond our local gravitationally bound neighborhood will continue to recede, not just farther, faster in the large-scale metric sense. Their light will become more redshifted, their visible activity more delayed, their future emissions less able to cross the widening geometry between us. The local group, dominated by the Milky Way, Andromeda, and their smaller companions, will remain bound and eventually merge into a single larger system. But beyond that island, the larger cosmic population will withdraw. Not because anything dramatic chases it away, because law continues uninterrupted. That is the severe thing about dark energy domination. It does not require catastrophe. It produces separation through consistency. If you run the standard cosmological picture forward, the distant universe does not explode. It thins, it reddens, it falls silent by degrees. The sky is not ripped open. It is administratively emptied. And that word matters here, emptied. Not in the old, naive sense of vacuum as mere lack, but in the newer, harsher sense that empty space is the medium through which isolation becomes the dominant condition. The more the universe expands, the more dark energy governs the expansion. The more dark energy governs the expansion, the more remote structures are carried beyond meaningful future contact. The process is self-consistent, mathematically elegant, and emotionally merciless. This is why the far future in a dark energy-dominated universe is often described as an island universe future. For observers unimaginably far ahead in time, assuming stars still shine somewhere and minds still exist to wonder, most galaxies beyond their own bound system would no longer be visible as part of an intelligible cosmic web. The large-scale structure we see today, with filaments and clusters across the deep sky, would be largely gone from observational access. The universe would appear smaller in knowable scope, even while being larger in actual scale. The future may not only be lonelier, it may be more ignorant. That is one of the most important consequences of acceleration, and one of the least emotionally assimilated. We tend to imagine scientific knowledge as something that accumulates naturally with time, as though future civilizations must inherit a clearer picture simply by arriving later. In many domains, that is true. Knowledge compounds, instruments improve, understanding deepens. But cosmology under accelerated expansion introduces a different possibility. Later observers may possess more local sophistication and less cosmic evidence. They may know more physics and see less universe. That inversion should be allowed to settle slowly, because it means our present vantage point is not generic. It is historically peculiar. We are late enough for heavy elements, rocky planets, chemistry, biology, and reflective minds to exist. But we are also early enough that the sky still carries readable traces of its origin and expansion. That is not guaranteed. It is temporary. The cosmic microwave background, for example, is one of the pillars of modern cosmology precisely because it remains detectable as a relic radiation field. But continued expansion stretches its wavelength ever further. Over vast future times, that background becomes colder, longer in wavelength, and increasingly difficult to observe. There comes a point at which practical detection may become impossible for any ordinary civilization embedded in a bound galaxy, especially if the expanding universe has carried most external structure beyond view. Likewise, with the Hubble expansion itself, today, the recession of distant galaxies is measurable because distant galaxies are visible in abundance. Their redshifts can be compared, their distances estimated, the large-scale law inferred. In a far future island galaxy, many of those empirical handles may disappear. A civilization there might see only its local merged remnant, perhaps surrounded by deep darkness, with little direct evidence that the cosmos was ever richer or more connected. Imagine trying to infer the Big Bang without the cosmic microwave background, without visible large-scale recession, without easy access to a richly populated extragalactic sky. The theory would be harder to earn, perhaps still possible indirectly. Perhaps some traces would survive in subtle local chemistry, ancient stellar populations, or the internal relics of nucleosynthesis. Perhaps brilliant minds would reason farther than we expect. But the point remains. The universe does not promise equal observational generosity to all epochs. Acceleration withdraws evidence, and that transforms the human meaning of cosmology in a way that broad, sentimental wonder often misses. We are not merely tiny creatures contemplating a large universe. We are creatures living during a narrow interval in which the universe is still, in a deep sense, legible. That is a different kind of grandeur, colder, more precise, less flattering, but more earned. Because it means our age may occupy a narrow window between two obscurities, too early in cosmic history, and the universe was too hot, too opaque, too chemically primitive for life like ours to arise and begin measuring anything, too late, and the evidence of cosmic history may be thinned beyond reach by the very expansion that shaped the large-scale future. We live not at the center of things, but inside a temporary corridor of visibility, a doorway in space-time, and the doorway does not stay open forever. This is where the question, what does it mean for humanity, stops sounding like an optional philosophical add-on and becomes part of the subject's internal logic. Because humanity, or any thinking species, does not receive reality whole. It receives what the universe permits to remain observable. Scientific truth is always filtered through causal access. The cosmos is not only whatever exists, it is also whatever can still arrive as evidence. That condition is easy to forget when the evidence is abundant. We live surrounded by successful inference. The relic glow of the early universe is measurable. Galaxy redshifts map expansion. Supernovae trace cosmic history. Large-scale structure preserves ancient acoustic patterns. The sky, even now, is carrying us an archive. But archives can burn without flame. They can disappear by dilution. This gives cosmic acceleration a peculiar emotional profile. It is not terrifying in the way black holes are often presented, devouring, crushing, immediate. It is not violent in the style of supernovae or gamma-ray bursts. It is calm, distributed, continuous. It changes the future not by breaking law, but by obeying it too faithfully. And that calmness is part of what makes it difficult to emotionally register. We are accustomed to associating significance with spectacle. Acceleration instead offers us something more adult, a universe whose deepest transformations can be almost silent. The silence is the mechanism. The sky empties because geometry keeps its word. And once you see that, another, deeper discomfort begins to form. Because we still have not answered the most dangerous question in the story. We have described what dark energy does. We have not explained what it is. That distinction is not a technical footnote. It is the fault line beneath the whole model. Because a universe whose future is dominated by an unknown component is not a completed picture of reality. It is a successful description wrapped around an unresolved ontology. And the better the measurements become, the more exposed that gap appears. That is the awkward dignity of modern cosmology. It is strongest exactly where it is least complete. We can say, with a high degree of confidence, that the large-scale universe is expanding, that the expansion history points to a hot and dense past, that gravity alone does not account for what the late universe is doing, and that some dark energy-like component fits a remarkable range of observations. All of that is real progress. None of it should be diminished. But there is a danger in the elegance of a successful model. Once the equations begin predicting accurately enough, the mind starts to confuse predictive success with final understanding. They are not the same achievement. To describe a pattern is not yet to possess the thing generating it. This matters because dark energy is one of those rare scientific concepts that becomes less comfortable the more honestly you phrase it. If it is the cosmological constant, then empty space seems to possess a persistent energy density built into the vacuum itself. If it is not the cosmological constant, then perhaps it is some dynamical field, something like quintessence, slowly evolving over cosmic time. If it is neither of those in the simplest form, then perhaps what looks like dark energy is really a clue that gravity itself, when extrapolated to the largest scales, is not exactly what general relativity says it is. Each of these possibilities carries very different implications, and none of them is emotionally tame. Vacuum energy is unnerving because it turns nothing into a physical term with measurable cosmic consequence. A dynamical field is unnerving because it means the dominant influence on the future of the universe may itself be changing, and the apparent calm of the current era may conceal a deeper time dependence. Modified gravity is unnerving because it suggests the geometry of space-time, the very framework through which modern physics interprets the cosmos, may still be incomplete where scale becomes extreme. In each case, the same lesson returns. The deeper layer is less intuitive than the visible one. And the embarrassment does not end there, because when physicists try to estimate vacuum energy using the tools of quantum field theory, the answer that naively appears is catastrophically too large compared with what cosmology observes. Not slightly too large. Not off in a way that invites patient refinement. Wrong by a magnitude so grotesque that it feels like an alarm built into the foundations of theory. This is the cosmological constant problem, and it deserves to be felt not just as a technical mismatch, but as a wound in coherence. On one side, the observed universe behaves as though empty space has a tiny but non-zero energy density that now dominates cosmic expansion. On the other, our most familiar ways of summing vacuum contributions in quantum theory suggest something incomprehensibly larger. The discrepancy is so enormous that ordinary language strains to carry it. It is not merely one of the biggest unsolved problems. It is a sign that two of the most successful frameworks in science, quantum field theory and general relativity, still do not sit together cleanly in one of the places where reality matters most. This should change how dark energy is emotionally held. Not as a neat chapter already mastered, as a stable observational fact sitting atop unstable theoretical ground. That distinction gives the story its mature tension. We are not wandering in ignorance. We are also not standing on finished understanding. We have enough truth to be deeply constrained and enough incompleteness to remain exposed. A measured wound in reality. That is why the current cosmological model, for all its success, should never be narrated as a closed triumph. It is too good a fit to be dismissed and too unfinished a framework to be worshipped. The responsible tone is neither skeptical theater nor complacent certainty. It is disciplined unease. And that unease has sharpened in recent years for another reason. The universe has begun disagreeing with itself about how fast it is expanding. This is where one of the most intriguing modern tensions enters the story, the Hubble tension. In simple terms, there are different ways to estimate the present expansion rate of the universe, known as the Hubble constant. One approach infers it indirectly from the early universe, especially from the cosmic microwave background, by fitting the data within the standard cosmological model and then projecting forward. Another approach measures it more directly in the later universe using distance ladders, supernovae, and other local indicators. Ideally, these approaches should converge on the same answer. They do not cleanly. The disagreement is not yet, by itself, proof that the standard model is broken. It could still narrow through better calibration, better understanding of systematics, or subtle but conventional corrections. Science has seen tensions before. Some vanish, some deepen. Responsible cosmology does not pretend the outcome is already known. But it also does not ignore the shape of the discomfort. Because if the Hubble tension survives every improvement and remains statistically robust, then it may be telling us that something in the standard account of cosmic expansion is incomplete. Perhaps the early universe contained a missing ingredient. Perhaps dark energy is not constant after all. Perhaps the neutrino sector behaves in a way not fully captured. Perhaps gravity or recombination, physics or some deeper assumption needs revision. Whatever the answer, the tension matters because it appears not in a corner, but in the very quantity that expresses the present expansion rate of the universe. The cosmos is arguing about its own pace. That is the kind of anomaly mature science must neither sensationalize nor smooth over. It should be held exactly where it belongs, not as proof of revolution, not as a footnote to be buried, but as a pressure point, a place where reality may be signaling that our best descriptive framework, however powerful, is not the final form. This is important for another reason too. If dark energy really is a pure cosmological constant, then its behavior is, in one sense, brutally simple: constant density, persistent influence, late-time domination, accelerated expansion continuing into the future. The story is elegant, and elegance has weight in physics. But if the true explanation deviates from that simplicity, if the equation of state of dark energy evolves even slightly, if cosmic acceleration changes character over time, if what we are seeing is really evidence of modified gravity, then the far future of the universe may not be exactly the one we currently project. Again, that does not mean anything goes. Observations constrain the possibilities severely. The standard model is not a random guess. It is an architecture built under pressure from many kinds of evidence, but the future may still depend on which hidden ontology eventually proves correct. This should make the subject feel more alive, not less grounded, because some of the most powerful scientific moments occur not when mystery is maximal, but when the mystery is fenced in so tightly that every remaining possibility matters. Dark energy has reached that stage. The unknown is no longer vague. It is shaped, and once the unknown becomes shaped, human significance changes again. Not in the cheap sense that we matter because we are asking questions. The universe does not grant importance so generously. The sharper truth is different. We happen to exist during a phase in cosmic history when the evidence is still available and the theoretical structure is advanced enough for the deepest open questions to become visible in their proper form. That is an unusual conjunction. Too early, and there would be no observers capable of framing the problem. Too late, and much of the observational leverage would have thinned away. Too primitive a physics, and acceleration would remain hidden inside noise. Too late a civilization, and perhaps the sky itself would no longer offer the same clues. We are not important because the universe is arranged around us. We are important to this question because we occupy the narrow interval in which the question can be asked well. That is rarer than wonder usually admits. And it prepares the ground for an even more severe recognition. Because if cosmic acceleration determines what can remain shared, and if our own epoch may be one of the few in which the universe is still richly knowable, then the story is no longer only about expansion, evidence, or theory. It is about timing, about the fact that consciousness may arise inside a cosmos that is already beginning to withdraw the very evidence of its own history. That may be the strangest human position in the whole story. Not that we are small. Smallness is easy. Smallness has become a cultural reflex. We say it almost automatically now, as though humility alone were insight. The deeper fact is not merely that we are tiny inside an immense universe. It is that we may have emerged during one of the few intervals in which the universe is still willing to explain itself. That is a more precise kind of unease. Because cosmic history is not equally readable from every moment within it, the early universe was too hot, too dense, too chemically primitive for beings like us. There were no rocky planets then, no stable biospheres, no long biological experiments in perception and memory, no patient instruments under dark skies trying to reconstruct the large-scale fate of reality. The universe had information, but no one to ask it coherent questions. The far future may reverse the problem. There may be minds, there may be local stars, there may even be extraordinarily advanced civilizations living inside gravitationally bound remnants of what are now galaxies. But the sky available to them may be poorer than ours in exactly the ways that matter most to cosmology. Fewer visible galaxies beyond the local island, more extreme redshifting of distant signals, a cosmic microwave background stretched so thin and cold that detecting it becomes vastly more difficult, perhaps practically impossible. Less direct evidence that the universe once looked radically different from the one immediately surrounding them. Between those two conditions lies a narrow interval. After opacity, before erasure. After structure forms, before most large-scale evidence withdraws. We live there, and once that is understood, the expanding universe is no longer just a question about matter and geometry. It becomes a question about epistemic weather, about the brief conditions under which reality is transparent enough for local creatures to infer the whole. That transparency is not permanent. It is an era. That alone would be enough to make cosmic acceleration emotionally significant. But it reaches further, because once you think in terms of knowability rather than mere size, the whole human situation begins to sharpen. Science is often described as though it were simply a method applied by minds to an indifferent world. That is true, but incomplete. Science also depends on what the world still permits to be seen. The laws may be eternal in whatever sense laws can be eternal, yet the evidence available to observers is historical. A truth may remain true long after the easiest path to discovering it has vanished. The Big Bang, for example, is not merely a philosophical deduction. For us, It is a model supported by multiple surviving traces: the cosmic microwave background, the abundance of light elements, the recession of galaxies, the large-scale structure of matter. Remove enough of those traces and the theory becomes harder to earn, even if it remains the correct description. That possibility should disturb the mind in a healthy way, because it means reality is not equally self-revealing across time. The universe does not stay pedagogical. And once the universe stops being pedagogical, the role of observers changes too. We are no longer just intelligence arising inside matter. We are intelligence arising inside a temporary corridor of evidence. Our theories do not float free of history. They are built inside a narrow opening where the cosmos has not yet redacted most of its own archive. That makes this age feel both privileged and fragile. Privileged, because the evidence is still here. Fragile, because it will not remain here indefinitely. This is one reason the phrase, "what it means for humanity," should not be allowed to collapse into sentiment. The meaning is not that the universe cares about us, or that cosmic acceleration grants us some flattering centrality. Quite the opposite. The meaning is that we are subject to the same severe geometry as everything else. Our thoughts, our telescopes, our theories, our civilizations, all of them operate inside a causal structure they did not choose. The expansion of the universe is not a backdrop to human history. It is one of the conditions under which human history becomes thinkable at all. Because to know a universe, signals must arrive. To build cosmology, traces must survive. To infer origins, the sky must still be carrying enough memory to be decoded. Acceleration narrows all of that. Slowly, quietly, by law. And this is where the story becomes almost cruel in its elegance. The same expansion that made room for galaxies, stars, planets, chemistry, and eventually minds also contains, in its later accelerated form, the mechanism by which much of the larger cosmos will withdraw from those minds. The universe becomes habitable, then intelligible, then progressively less legible again. First there is too much density for stable life. Then there is enough structure for observers. Then there is enough surviving evidence for cosmology. Then, much later, there may still be observers, but not the same sky. The arc is not random. It has a shape, a universe that opens itself just enough to be understood, then continues expanding into conditions that make that understanding harder to rediscover. There is something almost unbearable in that pattern once it becomes emotionally real. Not because it is tragic in the dramatic sense. The future does not need to be apocalyptic to be severe. The severity lies in the withdrawal, the thought that reality may be richest in knowable form only during a finite interval, and that conscious life like ours appears inside that interval, not at the center, not by cosmic invitation, but because certain physical conditions happen to overlap. We did not arrive in a generic universe. We arrived in a readable one. That is more haunting than grandeur. And it changes the meaning of observation itself. When astronomers map redshifts, measure supernova light curves, detect baryon acoustic oscillations, or refine the temperature anisotropies of the cosmic microwave background, they are not only advancing technical knowledge, they are participating in a race against cosmological forgetting. Not a race in the urgent human sense. We do not need to panic on behalf of trillion-year futures, but in the structural sense that some truths are available now in ways they may not always remain. This does not make science sentimental. It makes it historically situated. There is dignity in that, a severe kind of dignity. The universe is not arranged for our emotional comfort, yet it has, for a brief time, remained sufficiently transparent that a local species made of star residue and fragile chemistry can reconstruct much of its large-scale history. The reconstruction is incomplete. The ontology is unfinished. Dark energy remains obscure. The deepest unification of gravity and quantum theory still eludes us. But the opening is real. And openings matter. Because there is a difference between living in mystery and living in a mystery that can still be interrogated. We live in the second condition. At least for now, that phrase matters too. For now, it keeps the whole story from freezing into a clean philosophical slogan. The expanding universe is not a static piece of metaphysics. It is an evolving physical situation. What is observable changes. What is reachable changes. What remains inferable changes. The sky of one epoch is not the sky of another. The cosmos is not just a set of objects. It is a regime of access. And if access changes, then the old human dream of timeless knowledge becomes harder to hold in naive form. We prefer to imagine truth as something simply waiting out there, equally available to any sufficiently intelligent mind. In principle, perhaps some truths are. In practice, cosmology teaches something stricter. Intelligence does not meet reality on neutral terms. It meets reality through a window, and the window has a history. That may be one of the most mature lessons in all of science. Knowledge is not only about intelligence, it is about timing. And once timing enters the story this deeply, another unsettling question begins to rise. Not whether acceleration is real, not whether the evidence is strong, not even whether dark energy is constant or dynamical. The deeper question is, what sort of universe produces a situation like this at all? A universe in which the dominant late-time behavior is governed by something we barely understand. A universe in which local structure can flourish while large-scale contact decays. A universe in which consciousness appears not at the center of an eternal visible whole, but inside a temporary interval between primordial opacity and future erasure. At that point, the subject is no longer just expansion. It is the architecture of circumstance. And the final meaning of that architecture does not lie only in distant galaxies. It reaches all the way back to what we mean when we say that humans belong to the universe. Because belonging, in the shallow sense, is easy. Of course we belong to the universe. We are made of its elements, carbon from ancient stars, oxygen forged in stellar interiors, calcium, iron, phosphorus, silicon, all of it drawn from a long material history that began in a hotter, simpler cosmos and gradually complicated itself into chemistry, planets, bodies, and minds. In that sense, the old line is true. We are not outside the universe looking in. We are one of the things it has done. But that line is often used too quickly, as though material continuity were the whole depth of the relationship. It is not. There is a harsher form of belonging hidden inside cosmology. We belong not only because we are physically made of cosmic matter, but because our possibilities of thought are regulated by cosmic structure. Our sciences, our metaphors, our horizons of inference, even our intuition of what reality is like, all of them are conditioned by where in the expansion history we find ourselves. We do not simply arise in the universe. We arise under terms. That is the deeper implication of acceleration. It tells us that the relation between mind and cosmos is not timeless. It is staged by geometry. There are things we can know because certain signals still arrive. There are questions we can even formulate because the sky has not yet been emptied of the evidence that gives those questions shape. Our intelligence is not floating free above nature. It is embedded inside a specific causal arrangement, and that arrangement is temporary. This is where the phrase humanity in the cosmos becomes either serious or worthless. If it merely means that we are emotionally moved by stars, it remains decorative. If it means that consciousness is one of the rare forms matter takes when the universe becomes locally complex enough to reflect on its own conditions, while those conditions are still available to reflection, then the subject becomes much sharper. Then humanity is not a sentimental footnote to cosmology, but one of cosmology's strangest late-time consequences. A narrow interval of knowability producing creatures who can notice that the interval is narrow. That is a very different kind of grandeur. It is also a more dangerous one, because it offers no comforting centrality. We are not privileged because the universe was made for us. We are privileged, if that word can even be used, because we happen to exist inside a rare overlap, enough cosmic age for heavy elements in life, enough surviving evidence for cosmology, enough structural stability for science, and enough remaining transparency that the universe has not yet fully withdrawn from view. That overlap is physical, and physical overlaps can end. This is one reason modern cosmology, when felt honestly, tends towards something more austere than wonder. Wonder still belongs in it. The scale alone earns that. The elegance of the equations, the endurance of light, the fact that a local species can reconstruct a 13.8 billion year history from weak signals in the dark, none of that becomes ordinary merely because it is true. But wonder is not the final emotional register here, not if the story is followed all the way through. The more mature feeling is closer to tragic beauty. Because the same universe that generates stars and minds also arranges the conditions under which those minds can lose access to the larger whole. The same physics that permits cosmological understanding also limits its duration. The same expansion that gave the universe history is now, in its accelerated phase, stretching that history's surviving traces thinner and thinner across time. Reality is not only vast, it is perishable in its visibility. That line should be taken carefully, not perishable in existence. Galaxies will not vanish because we stop seeing them. The universe is not created by observation, and cosmology must never drift into that confusion. But perishable in visibility. Yes, perishable in shared access. Perishable in the sense that evidence can become inaccessible even while the underlying reality continues perfectly well without us. This matters more than it first appears. Because science is not built out of reality in the abstract. It is built out of reality as available to evidence. When evidence thins, science does not become impossible in every domain, but certain inferences become harder, and some may become practically unreachable. A civilization in the far future may become superbly knowledgeable about local physics, while remaining impoverished about cosmic history. It may master fields and particles, while lacking the observational sky that made the modern, expanding universe picture possible. In that sense, acceleration does not merely change the content of the future sky. It changes the intellectual ecology of future minds. What kinds of metaphysics become plausible when the sky is mostly empty? What theories of origin survive when the background radiation is undetectable? When external galaxies have receded beyond view? When the visible cosmos appears bounded almost entirely by one gravitationally bound island? What becomes of a mind trying to infer total reality from a vastly reduced archive? These are not idle questions. They reveal something severe about our own position. We often imagine ourselves as the epistemic underdogs of history, primitive compared with whatever minds might come later. And in many local respects, that may be true. But in cosmology, the situation may invert. Later minds may inherit better tools and a poorer sky. That means we are not simply early in a developmental sense. We are early in an evidential sense. The distinction is subtle and important. It is one thing to say we live near the beginning of the universe's long story of stars and structure. In truth, we do not. Many billions of years had already passed before Earth formed. Another thing entirely is to say that we live during one of the richest epochs for reconstructing the large-scale story, that may, in a deep and narrow way, be true. And if it is true, then one consequence follows almost immediately. Scientific responsibility acquires a cosmological dimension. Not because we must melodramatically save the universe's secrets, but because we occupy an observational moment that will not recur in the same form. Knowledge preserved is not merely local cultural capital. It is one way a transient window of legibility can outlast the conditions that made it easiest to open. That gives scientific civilization a severe dignity. To observe carefully, to infer honestly, to preserve what has been learned without inflation or myth, to distinguish what is established from what is inferred from what is speculative, and what remains genuinely unknown. All of that matters even more under acceleration, because the subject itself is partly about the fragility of access. If the universe gradually withdraws its archive, then intellectual honesty becomes not just an ethical virtue, but a structural necessity. We cannot afford to romanticize where clarity is required, and we cannot afford false certainty where the ontology remains unresolved. This is why the dark energy question must remain disciplined. The temptation, whenever science reaches a boundary like this, is to fill the gap with rhetoric, to turn the unknown into a mystical reservoir, a poetic license, a place where language can pretend to float free of rigor. But that is a betrayal of the subject. Dark energy is not valuable because it gives us room for fantasy. It is valuable because it gives us a real effect whose explanation remains incomplete and forces us to live in the tension between successful measurement and unfinished understanding. That is a more interesting condition than certainty, and perhaps a more adult one, because the universe, at its deepest scales, does not seem arranged to satisfy the emotional preferences of primates. It does not simplify as knowledge deepens. It often does the opposite. Space becomes dynamic. Time becomes relative. Matter becomes structured emptiness. Gravity becomes geometry. The universe expands. The expansion accelerates. Empty space enters the equations as an active term. Horizons emerge. Shared reality narrows. Evidence itself becomes historical. Each step is lawful. None of it is psychologically natural. And this is where the topic begins to widen one last time. Expansion is no longer just about why galaxies recede, or why supernovae came back faint, or why the cosmological constant returned from Einstein's abandoned term. It becomes part of a larger recognition. Reality is not built to be intuitively possessed. The mind does not begin in truth and then add detail. It begins in useful fictions and gradually learns which of them must be surrendered. The expanding universe is one of the grandest examples of that surrender. At first, the sky looks still, then it moves, then motion becomes metric, then a hot, dense past appears, then gravity should slow it, then it does not, then emptiness acquires causal force, then the future becomes a sequence of withdrawals. Then the observer realizes that even observation itself belongs to a narrow historical corridor. By the time you reach that point, the original question, why is the universe expanding, has become almost too small. Because the mature form of the question is no longer about expansion alone. It is about what sort of reality produces beings who can discover that the world is deeper, stranger, and less permanently accessible than the visible present suggests. And the answer to that question cannot be only scientific in the narrow sense. It must also be existential, because it concerns what it means to be a finite intelligence inside an unfinished cosmic structure. Which means we are approaching the last turn now. Not toward a conclusion that wraps the subject up, toward a realization that changes the opening from within. Mind expects to inhabit a fixed stage, objects moving across it, distance as a neutral backdrop, emptiness as absence, time as a shared current, knowledge as something that becomes easier simply by arriving later, a universe that may be vast and difficult, but is still, in its deepest architecture, psychologically legible. That is the illusion that has been dissolving all along. The expanding universe first appears to violate only one part of that picture. Space is not fixed, fine, strange, but perhaps containable. Then the violation spreads. The past becomes hotter, denser, less intuitive than anything immediate experience would have predicted. Gravity, which should have moderated the expansion, loses large-scale dominance. Empty space stops behaving like emptiness. Horizons appear, shared visibility contracts. The future ceases to be merely far away and becomes selectively inaccessible. And finally, the observer discovers that even the act of knowing the cosmos depends on existing inside a narrow interval before much of the evidence is carried beyond reach. By then, the subject has outgrown the language of interesting facts about the universe. It has become a confrontation with a harder truth. Reality is not arranged in the image of intuition. And that matters because intuition is not some disposable ornament in human life. It is the operating system of ordinary consciousness. It is how the body organizes the world well enough to act, survive, trust surfaces, navigate rooms, judge motion, feel solidity, assume continuity. Intuition is not stupid. It is locally successful. But modern cosmology is one of the places where local success becomes global betrayal. The instincts that work on Earth, at human scale, under ordinary conditions, do not scale upward into truth without breaking. That is why the expanding universe feels so different once it is fully understood. Not merely bigger than expected, not merely stranger, more disciplinary than that. It teaches that what feels fundamental may be derivative. What feels stable may be historical. What feels empty may be active. What feels visible may be temporary. What feels knowable may belong to an era rather than to reality in any timeless sense. This is not nihilism, it is precision. The universe does not become less real when intuition fails. It becomes more exacting. And once that is allowed to settle, a more mature image of humanity begins to appear. Not humanity as the center of the cosmos, and not humanity as a meaningless speck inside a decorative infinity. Both of those pictures are too easy. One is flattery. The other is a pose. The truer image is harder to hold. We are local creatures produced by a universe that is lawful enough to generate complexity, long-lived enough to permit biology, structured enough to form stars and chemistry, and temporarily transparent enough to let some of its own history remain infallible. We are not outside that structure. We are one of its late emergent consequences, but neither are we incidental in the shallow sense of being unrelated to the larger architecture. Our very ability to ask cosmological questions is itself a cosmological event. Matter, after billions of years of cooling, clustering, burning, collapsing, dispersing, and recombining, produced a form of local organization capable of noticing that the universe is expanding. That is not sentimental. It is one of the actual things the universe did. And what gives it weight is not that consciousness somehow conquers cosmic indifference. It does not. The galaxies will continue to recede. The horizons will continue to harden. Dark energy, whether cosmological constant, field, or sign of deeper incomplete gravity, will continue to govern the large-scale future, whether anyone watches or not. Human feeling does not negotiate with the equations. But attention still matters. Because there is a profound difference between a universe that is merely happening and a universe in which some small part of what is happening becomes visible to itself. Not visible in total, not visible finally, but visible enough that the structure can be partially reconstructed from within. This is where the old phrase about the universe becoming conscious of itself usually enters, and usually enters too cheaply. It is often used as consolation, as though awareness itself redeemed scale, violence, indifference, and loss. That is not serious enough for what the subject has actually shown us. Awareness does not redeem the cosmos. It does something subtler. It creates a temporary resistance to erasure. Not physical erasure, not the kind that stops expansion or cancels horizons. Something more fragile than that, a cognitive resistance, a brief interval in which the universe's withdrawal is met by description, measurement, theory, memory, a moment in which the sky has not yet gone dark enough to conceal its own beginning, and local minds have become capable of reading what remains. That may be the deepest dignity available to a finite intelligence, not mastery. Witness, when understood properly, is not passive. It is a discipline. It requires rigor, self-correction, patience, restraint in the face of mystery, honesty in the face of uncertainty, and the ability to endure a reality that does not simplify itself for comfort. Cosmology at its best demands all of that. It asks the mind to let go of the obvious world without falling into fantasy, to accept lawful strangeness without turning it into mythology, to say what the evidence supports, no more and no less, even when what it supports is already severe enough. And severity is exactly what the expanding universe offers when stripped of decoration. A universe with a history rather than a static frame, a history with a direction rather than a timeless arrangement, a direction in which matter's local richness coexists with large-scale withdrawal, a withdrawal governed not by disaster but by law, a law that may, in the far future, leave minds with less cosmos to read than we possess now, a present in which the archive is still open, but not forever. That is not the sort of truth that leaves the world unchanged after you hear it. It alters the emotional meaning of the night sky. The stars are no longer just distant lights. The galaxies are no longer just scenery. Darkness is no longer merely dark. Distance is no longer neutral. Even emptiness is no longer empty. Everything visible begins to feel historical. Every photon feels delayed. Every spectrum like testimony. Every deep field image like a temporary mercy. The sky stops looking like a permanent display and starts looking like a diminishing inheritance. And yet the feeling that remains at the end should not be despair. Despair is too blunt for this subject. The universe is not punishing us. It is not singling us out for loss. It is unfolding according to structures far older and deeper than anything human. The proper feeling is colder and clearer than despair. Something closer to gratitude without comfort, to awe without innocence, to melancholy without self-pity. Because the fact that the window is narrow does not make it meaningless. It makes it exact. The fact that the cosmos is withdrawing does not cheapen the moment in which it can still be read. It sharpens it. If anything, acceleration gives observation more weight, not less. It means that looking carefully is not a casual luxury of an endlessly available world. It is participation in a rare interval of legibility. We are able, for now, to see a universe that still bears obvious traces of its beginning, its expansion, its geometry, and its changing fate. That for now should never be spoken dramatically. It is already dramatic enough, because this is what the universe ultimately seems to be, not a static masterpiece hung in darkness, but an evolving structure that grants and withdraws access according to law, a reality in which even understanding has a cosmological context, a world where the deepest truths are not hidden behind supernatural curtains, but scattered across distance, stretched into spectra, embedded in relic radiation, written into clustering patterns, and made available only to those epochs in which they can still arrive. That is what the expanding universe means for humanity. Not that we are central, not that we are saved by understanding, not that the cosmos was waiting to be admired, something harder, that we live inside a brief period when the universe has not yet hidden most of itself. And that may be one of the rarest conditions in all of reality. Rarity changes the emotional scale of everything that came before it. At the beginning, the expanding universe sounded like a mechanism, galaxies receding, light stretching, a hot, dense past emerging from backward inference. Gravity expected to slow the motion, supernovae arriving too faint, empty space entering the equations with the wrong kind of authority, horizons forming, the future losing contact by degrees. All of that is still true. But once the whole structure is seen together, the meaning shifts. Expansion is no longer just something the universe is doing. It becomes part of the conditions under which any creature inside the universe can have a relationship to the whole at all. That is the larger fracture. Because we are used to imagining reality as something fully there, fully formed, with our ignorance as the only real barrier. We do not know enough, so we investigate. We build better instruments. We refine our theories. Time, in that picture, is mostly an ally. The future inherits more. Ignorance retreats. Truth remains in place, waiting. Cosmology under acceleration complicates that faith. Not by making truth unreal, by making access historical. There is a difference between the universe being there and the universe still being available as evidence. That difference is easy to miss because we live in an era saturated with successful inference. The cosmic microwave background still washes through space as a detectable afterglow. Distant galaxies still fill deep images densely enough to expose the large-scale expansion. Baryon acoustic oscillations still survive as measurable structure. The relic signatures of a hot origin are still recoverable. Even the tensions in the data, the unresolved pressure around dark energy, the Hubble tension, the awkward incompleteness of the Standard Model are signs of abundance. We have enough evidence for the unknown to take shape. That abundance will not define all eras. And once that lands, the human condition inside cosmology becomes stranger than either arrogance or insignificance can describe. We are not important because everything depends on us. It does not. We are not unimportant because we are small. Size is the wrong metric. The more precise statement is harder. We are local beings occupying a globally unusual moment. A moment in which the universe has aged enough to produce complexity, but not aged so much that most of its large-scale history has disappeared from view. A moment in which space is already old, stars are already mature, heavy elements already exist. Planets can hold chemistry long enough for biology to persist. And yet the sky still carries enough surviving evidence that minds can reconstruct a deep past and infer a deep future. That overlap is not eternal. It may not even be common. And if it is uncommon, then consciousness in this form acquires a different kind of significance. Not metaphysical supremacy, not cosmic centrality, observational significance. A narrow region of space-time in which the universe remains richly interrogable has produced organisms capable of asking what the universe is. That is one of the most severe coincidences in the entire story. The word coincidence should be handled carefully here. It does not mean magic or intention or hidden design. It means overlap under law, a physical conjunction of conditions, enough structure, enough time, enough transparency, enough stability, enough remaining evidence, enough intelligence, enough patience, enough luck. That is what makes the whole thing feel at once lawful and improbable in the everyday emotional sense. The universe did not need to become readable. It merely did for a while. And that, for a while, is where the subject reaches its sharpest edge. Because once access is understood as temporary, understanding itself becomes more fragile than we like to admit. Human beings often speak as though knowledge, once achieved, simply lives forever in the abstract. But knowledge requires preservation. It requires institutions, memory, continuity, material support, language, archives, disciplines, habits of rigor, and civilizations capable of carrying insight across generations. The universe may still be legible now, but if local intelligences fail to preserve what has been learned, future minds may not stand in the same relation to the sky, even if they are descendants of ours. This gives science a weight beyond curiosity. To measure carefully, to infer honestly, to preserve models without inflating them into mythology, these are not merely academic virtues. They are one way a transient observational privilege is prevented from vanishing without residue. If future eras are poorer in cosmic evidence, then what is known now is not only information, it is a rescued relation to reality. There is something almost unbearably dignified in that. Not because humanity becomes heroic in some inflated sense. Heroism is too theatrical. The better word is stewardship. Stewardship of a rare opening. Stewardship of signals that arrived before the geometry became less forgiving. Stewardship of a sky still crowded enough, transparent enough, and mathematically interpretable enough to reveal that reality is older, stranger, and less intuitive than the present world suggests. And the duty of stewardship is sharpened, not softened, by uncertainty. We still do not know what dark energy is. We do not know whether the cosmological constant is the final answer, whether a deeper dynamical field is involved, whether gravity itself requires modification at the largest scales, or whether some future synthesis between quantum theory and space-time will make the present vocabulary look provisional. That incompleteness is not an embarrassment to be hidden. It is part of the moral atmosphere of the subject. We know enough to be humbled. We do not know enough to relax. That combination is rare and valuable. It is also what prevents the story from collapsing into one of two cheap endings. The first cheap ending is triumphal. Science has solved the cosmos. The mystery is essentially over. Dark energy is just another term waiting to be tidied up. That is false. The second cheap ending is mystical. The unknown is so vast that rigor no longer matters. Poetry can replace explanation. Uncertainty licenses fantasy. That is also false. The truer ending is narrower and more severe. We have seen enough to know that the universe is not built the way intuition first told us. Enough to know that space can evolve, that expansion has a history, that acceleration is real, that empty space is not cosmologically innocent, that horizons limit future contact, and that our observational era may be unusually rich. But we stand inside those recognitions without final possession of the ontology beneath them. That is not failure. That is maturity. A mature cosmology does not promise the emotional satisfactions of closure. It offers something better and less consoling, a map of where the world resists us, where the evidence is strongest, where the explanations hold, where the words are placeholders, and where reality has already outrun the pictures the mind prefers. It is worth lingering there, because this is where the subject becomes almost ethical. The expanding universe teaches restraint. It punishes exaggeration. It punishes laziness in metaphor. It punishes the desire to make the cosmos simpler, friendlier, or more theatrical than the evidence allows. A serious narration of expansion has to withstand both sentimentality and sensationalism. It has to let the truth remain large without becoming vague, and severe without becoming melodrama. That is perhaps the deepest reason the topic matters, not only because it describes the universe, but because it trains the mind in the discipline required to meet reality when reality is lawful, immense, and not arranged for psychological ease. The adult lesson is not that the universe is mind-blowing, it is that the universe is exacting. It asks us to trade intuitive comfort for measured strangeness, to accept that the visible is not the fundamental, that the fundamental may not be fully understood, and that understanding itself belongs to a cosmological interval rather than to some timeless entitlement of intelligence. By this point, the original question has changed shape completely. Why is the universe expanding? Because space-time is dynamic, because general relativity allows, and in many forms requires, cosmic evolution, because the universe emerged from a hotter, denser past, because its contents determine its expansion history, and because, at late times, a dark energy-like term dominates the large-scale behavior. All true, but not enough. The grown version of the question is harsher. What kind of reality gives rise to local minds during one of the few eras in which the whole can still be partially reconstructed, even as the future of that whole is one of increasing separation? That question cannot be answered with one more data point or one cleaner equation. It sits at the junction of physics and condition, and the answer, whatever else it contains, must include this. A universe does not have to care in order to be briefly knowable. That is the line the subject has been moving toward all along. The knowability is real, the indifference is real, the overlap is temporary, and we are inside it. And inside it, something almost paradoxical becomes visible. The universe is least comforting precisely where it is most intelligible. That is not how the human mind expects truth to behave. We tend to imagine understanding as a form of reconciliation. The better we know something, the more at home we should feel within it. Ignorance is the source of fear. Knowledge should quiet it. In many parts of life, that is true. Learn the mechanism, and the dread recedes. Learn the structure, and the chaos becomes manageable. Cosmology does not always grant that mercy. The expanding universe becomes more lawful as we understand it, but not more domesticated. If anything, the opposite happens. The old picture, fixed space, neutral emptiness, gravity gradually calling things back into order, knowledge accumulating into ever clearer possession, was emotionally easier. The modern picture is sharper and less forgiving. Space changes. Expansion has a history. Gravity loses the large-scale argument. Empty space behaves like a term in the future of reality. Horizons harden. Evidence itself belongs to an era. The universe does not become irrational under examination. It becomes exact in ways the body would never have asked for. That exactness is the real source of the unease. Because chaos can be dismissed as failure of understanding, law cannot. When the cosmos is lawful and still refuses our deepest intuitions, then the discomfort reaches a different level. It is no longer fear of the unknown in the simple sense. It is the recognition that the known already exceeds psychological comfort. And that recognition changes the emotional meaning of human life inside the universe. Not by making us more important, by making our moment more precise. We are, it seems, late enough to inherit a universe with galaxies, stars, chemistry, planets, and time for biological complexity to ripen into reflection. But we are also early enough that the larger cosmos has not yet withdrawn beyond inference. The night sky still contains a readable density of external galaxies. The cosmic microwave background still traverses space as a surviving afterglow. The expansion is still measurable. The relics of a hotter beginning are still distributed through observation, spectroscopy, structure, and radiation. That conjunction should feel extraordinary not because it flatters us, but because it does not. It is a narrow permission, not a cosmic compliment. We did not earn the interval. We appeared inside it. That distinction matters. It prevents the whole subject from collapsing into a disguised anthropocentrism. There is no need to pretend the universe arranged itself for our benefit. The laws are sufficient. Matter evolved, structure formed, time passed. Biology happened under local conditions. Intelligence emerged, and in at least one small place. Intelligence became capable of reading large-scale reality before large-scale reality had finished redacting itself from the sky. That is enough. More than enough, in fact, to make the human situation feel stranger than either religion or reductionism usually permits. We are neither the appointed center of creation nor trivial dust in a meaningless machine. Those are both simplifications. The first gives us too much metaphysical privilege. The second gives us too little structural importance. The truth seems harsher and more interesting. We are temporary knowers inside a temporary opening. Temporary in lifespan, temporary in civilization, temporary in species, temporary even more deeply. In the cosmological accessibility of the world, we are trying to understand. That makes knowledge feel less like possession and more like contact. A brief contact between local consciousness and a wider reality that does not stay equally available forever. There is something almost sacred in that idea if one strips the word sacred of comfort and keeps only its seriousness. Not sacred because it is supernatural, sacred because it is irreducibly weighty, because it asks to be handled without vanity, without hysteria, without decorative profundity. The expanding universe, honestly understood, does not need exaggeration. It is already severe enough, already elegant enough, already capable of altering the way one stands under the sky. To stand under the sky after understanding this is to stand differently. Not because the stars change, because the meaning of distance changes. A point of light is no longer just remote. It is delayed. It is historical. It is a message that crossed a changing geometry to arrive. A galaxy is no longer merely an island of stars. It is part of a larger law of separation. Darkness is no longer the absence of visible objects. It becomes, in part, the space in which access is thinning. Even the idea of the universe becomes harder to use casually, because the word now contains distinctions the instinctive mind once ignored. The observable universe, the reachable universe, the future light cone, the horizon beyond which events will never belong to our causal future. The cosmos becomes less like a possession and more like a relationship under constraints. That may be one of the deepest things science can teach without leaving science behind. Because relationships under constraints are exactly what finite beings understand best. Once the abstraction is translated properly, we know what it is to lose touch. We know what it is for time to remove possibilities. We know what it is for a window to close, for access to narrow, for memory to matter, because presence cannot be preserved indefinitely. Cosmic acceleration is not human in any sentimental way, but it produces a formal analog of those truths at the largest scales. Not grief, exactly, not loneliness in the emotional sense, something more impersonal, but recognizable. The widening of separation until shared reality itself becomes local. That phrase should be allowed to echo. Shared reality becomes local. Not reality itself. Reality is under no obligation to become smaller because our access becomes thinner. But the portion of it that can still be held in mutual causal relation contracts relative to the whole. In that sense, the far future does not simply contain fewer visible galaxies. It contains a diminished common cosmos. And if that is true, then our own era acquires a burden as well as a privilege. To live while the common cosmos is still richly visible means that our descriptions matter, our measurements matter, our honesty about uncertainty matters. The preservation of what has been learned matters. There is no need to inflate this into grandiose mission language. The point is quieter and more exacting than that. If the universe offers a narrow period in which it can still be reconstructed at large scale, then a civilization that squanders that period through confusion, vanity, anti-intellectual theater, or indifference is not merely making a cultural mistake. It is failing to answer a real condition of existence. That may sound austere, but austerity belongs here. The expanding universe does not ask us to be impressed. It asks us to be worthy of clarity. Worthy not in the moralistic sense of cosmic reward. There is no reward coming. Worthy in the simpler sense of adequacy. Adequate to the evidence, adequate to the difficulty, adequate to the distinction between what is known and what is merely named, adequate to the temptation to turn mystery into brand, slogan, myth, or therapeutic fog. Dark energy is especially merciless on this point. It offers just enough mystery to seduce language into inflation, and just enough evidence to punish that inflation if one remains honest. We know the late universe behaves as though dominated by a dark energy-like component. We do not yet know, at a fundamental level, what that component is. The dignified response to such a condition is neither reductionist boredom nor mystical excess. It is disciplined patience, to hold a real effect without counterfeit closure. That is also part of what the expanding universe means for humanity. Not simply that we learn a fact about the cosmos, but that the cosmos forces a certain maturity of mind, one that can live without immediate comfort, without theatrical certainty, without collapsing lawful strangeness into either cynicism or myth. A maturity willing to let reality remain both intelligible and unfinished. And perhaps that is the deepest correction hidden inside all the others. The universe is not strange because it withholds law. It is strange because law, followed far enough, outruns familiarity. That is what the first wrong feeling about space eventually became. It was never just the mistake of picturing galaxies moving through a fixed void. It was the larger mistake of assuming that if reality is lawful, then reality must eventually resemble an enlarged version of what the organism already knows how to feel. Cosmology breaks that faith cleanly. The lawful can remain alien. The exact can remain emotionally unresolved. The true can remain severe. By now, the final realization is close enough to name without diminishing it. The universe is expanding. Yes, space grows. Light stretches. Galaxies recede. Acceleration hardens the future into increasing separation. All of that is part of the story. But beneath those facts lies the deeper one. The universe is not only becoming larger, it is deciding, by law, what can still remain part of the same knowable world. And we live in a brief age before most of that decision has finished expressing itself. And that is why the final meaning of cosmic expansion was never going to be captured by the image of things merely moving apart. That image is too small, too mechanical, too emotionally thin for what the science actually reveals. Because what has been unfolding across all of this is not only a story about recession velocities, redshifts, supernovae, vacuum energy, or even the fate of distant galaxies. It is a story about the terms under which reality remains shareable. A story about the fact that the universe is not a static totality waiting patiently to be known in the same way by any mind at any time. It is an evolving structure, and that structure governs not just what exists, but what can still belong to a common horizon of evidence. The deeper shock was never that the universe is expanding. The deeper shock is that expansion, once accelerated, becomes a law of selective disappearance. Not disappearance into non-existence. That would be easier, in a way. Easier because it would feel like destruction, and destruction is something the mind already knows how to picture. What the expanding universe gives us instead is more difficult than destruction. It gives us withdrawal. The galaxies remain. The larger cosmos remains. The unreachable regions remain fully real, but reality and accessibility begin to separate. Existence continues while relation thins. That is colder than catastrophe. Because catastrophe announces itself. It breaks things in public. It produces a before and after. Acceleration is quieter than that. It acts by patient consistency. The future is redrawn not through rupture, but through obedience to law. Space continues to expand. The influence of dark energy continues to dominate. Horizons continue to define what can ever be exchanged, observed, inferred, or reached. The common cosmos narrows not because something has gone wrong, but because the equations continue to work. That may be the most adult kind of cosmic unease. A universe that does not need drama to become severe. And once that is seen clearly, the human place inside the picture changes one final time. not upward into importance, not downward into worthlessness, sideways into condition. We are not the center of the universe. We are not its purpose. We are not the reason it became legible for a while. But we are one of the forms it took during an era in which legibility still existed at scale, a local structure of carbon, water, memory, and abstraction appearing inside a cosmos old enough to generate complexity and still transparent enough to let complexity reconstruct its history. That is not a consolation prize. It is stranger than consolation, because it means that what we call human understanding is not an escape from the universe. It is one of the transient relationships the universe permits with itself before larger separation hardens further. Our cosmology is not a detached map drawn from nowhere. It is the temporary self-description available to a local intelligence during a narrow interval of access. In that sense, knowledge is not ownership. It is contact, brief contact, disciplined by evidence. And perhaps that is the line that matters most at the end. We speak so often as though science were the conquest of mystery, as though explanation were a slow annexation of the unknown into the stable territory of the known. But the expanding universe suggests something more severe and more beautiful than conquest. Not conquest. Encounter. An encounter between finite minds and a lawful reality that exceeds them, during a period when enough of that reality still arrives in forms that can be measured, light reaches us, relic radiation reaches us, structure remains visible, spectra remain readable. The universe has not yet hidden most of its beginning behind the long arithmetic of accelerated distance. That condition will not last forever, and the fact that it will not last forever does not cheapen it. It makes it exact. This is where a weaker script would try to comfort the viewer. It would say that none of this matters because we are here now, or that human meaning transcends cosmic scale, or that consciousness somehow redeems the indifference of space-time. But that would be a retreat from what the subject has earned. The truth is stronger without consolation. The universe does not need to care in order for this moment to matter. The fact that the opening is temporary is precisely what gives it weight. The fact that the cosmos is withdrawing does not make the act of seeing it trivial. It makes the act of seeing it rare. To look out and find not just stars, but evidence, not just beauty, but history, not just distance, but law, not just law, but the limits law places on future knowability. That is not the emotional failure of a small species. It is one of the most improbable dignities matter has achieved. A brief resistance to cosmic forgetting. That phrase should be handled carefully. Not resistance in the sense of changing the future of expansion. We do not bargain with dark energy. We do not reverse horizons by noticing them. We do not hold the galaxies near us by loving them more intensely. The resistance is cognitive, archival, theoretical, a small, local refusal to let the available universe pass through consciousness without being described, a commitment to witness before the wider sky grows thinner still. And witness, in the end, may be the highest honest role available to creatures like us. Not rulers of the cosmos, not its chosen interpreters. Witnesses who arrived late, but not too late, who inherited a universe already ancient, already expanding, already structured by processes far older than life, and still found that enough of its record remained to reveal something astonishing. That reality is dynamic where it looked fixed, historical where it looked given, active where it looked empty, and temporary in its visibility where it looked permanently available. The universe did not merely become larger than our ancestors thought. It became less intuitively possessible. And that is why the final realization should not land as a fact, but as a change in perception. The night sky is no longer a permanent ceiling of lights. It is a vanishing archive. Distance is no longer just remoteness. It is time under tension. Emptiness is no longer absence. It is part of the mechanism. The future is no longer simply what comes after us. It is a narrowing of shared reality. And humanity is no longer just a clever species standing under stars. Humanity is one momentary expression of matter during an era when the universe has not yet hidden most of itself. That is what it means. Not that we were made for the cosmos. Not that the cosmos was made for us. But that for a brief interval, the two remain in contact strongly enough for understanding to happen at all. And maybe that is the most haunting truth the expanding universe leaves behind. Not that everything is moving away, not even that acceleration will continue to widen the silence, but that we live before the silence is complete, before the background has faded beyond ordinary reach, before the distant galaxies have all withdrawn from the visible web, before the evidence has thinned into something harder for future minds to recover. We live inside the afterglow of readability, a temporary brightness in the long geometry of separation. One day, on scales too vast for grief and too lawful for protest, much of what now fills the deep sky will belong no longer to any common future. The universe will go on, larger, colder, more isolated in its visible structure, less generous with evidence, less crowded with signals crossing the dark, perfectly real, less shared. And long before that remote age arrives, the truth has already changed the present. Because once you understand what expansion really is, you do not look at the cosmos the same way again. You look at every distant light as something that had to survive a changing universe to reach you. You look at every measurement as part of a narrow opening in time. You look at cosmology not as a luxury of curiosity, but as a record made during one of the few eras when the whole can still be partially inferred. And you realize that the universe is not only expanding away from us, it is deciding, with perfect indifference and perfect law, what can still remain part of the same knowable world. For now, we are still inside that world. For now, the archive is still open. For now, the sky still remembers enough to be read. And that may be one of the rarest things that will ever happen in all of reality.